So when it comes to the variety of 3D programs on the market, why should you use Houdini? What makes it unique and sets it apart from other programs? Well, to answer this, we're going to use an analogy. So let's imagine that working in 3D software is like driving a car. Now, you could drive that car incredibly well, or you could be terrible. But you could practice and get better. You can drive faster, take the corners perfectly, and win races. But no matter how good you are, you could never drive that car to the moon. Your skill is limited by the constraints of the vehicle itself. But using Houdini is more like being a mechanic or an engineer. Want to win more races? Then build a faster car. Want to visit the moon? Then slap a jet engine on there. Your only limitation is your imagination. And that sounds great, right? But the problem is, what if you're not an engineer? How do you learn all of this? Where do you even start? Can you imagine if day 1 of Engineering Academy started like this? Okay class, step 1, mine some iron ore. Step 2, melt it down and forge some nuts and bolts. Step 3, cast a flat sheet of steel 16 inches wide and drill exactly 8 holes 2 inches apart. No, absolutely not. You'd start with a car, a fully assembled, fully functional car. You'd learn how to change the tires or swap out the rims. Maybe replace the exhaust pipe for a bit of improved performance. Only then would you add the jet engines and the gun turret, right? The point is, you'd learn the basics by tweaking, altering, or replacing parts on an already functioning system. And then over time, as that becomes more familiar, you would start building certain parts from scratch, or building something unique that has never been seen before. And this is exactly the approach we are going to take on this Houdini Fundamentals course. I'm going to show you how to use the pre-built tools that Houdini has to offer as a really good starting point, and then how to tweak those to your needs, but more importantly, to learn from those setups, so over time you can rely on them less and less. By the end of this course, we will have covered almost all of the major aspects and features of Houdini and a wide range of different effects, but at a complexity level that is manageable. And by taking this approach, you'll be able to get up and running in no time, using Houdini in a variety of ways without being overwhelmed by too much information. And then through practice and time, we can layer complexity on top of those rock-solid fundamentals. This course is aimed at anyone who is new to Houdini, as well as those who wish to enhance their understanding of the fundamental principles that Houdini is built upon, in order to improve their more advanced effects work. And because these foundations are so important, this course will be a prerequisite for all other Rebel Way courses. So whether you want to become an explosives master, a procedural guru, or a dynamics dynamo, your journey begins right here. Alright, so this is basically Houdini as it would be if you've just had a fresh install. Okay, so this is the sort of default layout that if you open it up and I open it up on my side, it should look exactly the same. Okay, and basically this course is taking the assumption that you are brand new to Houdini, so either never opened it before, or have maybe opened it, fiddled around with it a little bit before, maybe tried 1 or 2 things and not really gone much further. Okay, so this is the fundamentals of Houdini, right? And by the end, we're going to start, covering some really cool things. But obviously in the beginning, there's normally the sort of phase of learning just how to navigate and what each tool is. And that is very important information, and we are going to cover it. But most courses tend to just start with that stuff and just front load it, just everything like that up front. And it tends to just be a bit overwhelming, a little bit too much, just very dry information about like all these different controls on your keyboard and how to navigate the scene. And that doesn't stick in your mind because it's not really relevant to anything we're doing at the time. Okay, so I'm going to take a different approach here, and we're going to learn those controls as and when we need them. So when we need to move around the viewport, then I'm going to show you how to do that and so on. So then hopefully that will be a little bit more interesting to you and also will stick in your mind a bit better. Now, one of the things I find is that there's this kind of a fear of a blank canvas, right? I mean, I remember even in art class, they were, one of my instructors was just like, you know what, first thing, just put a dot in the center of that canvas, and then, okay, now let's go, because now you're less precious about this perfect canvas. Well, it's kind of the same here. We've got nothing, and then it tends to be this very intimidating program, especially if you're brand new to it and never touched it before, that, we kind of just want to break that. We're going to break the ice here, and we're going to just do something cool so that you can see how easy it is, see that this is not a program to be overly intimidated by, and then we'll move on to the sort of the other relevant information that you need to know. So this first lesson is just going to basically be a bit of a step-by-step follow along. I'm not going to explain in depth all the details of what we're looking at, because that would be too sort of long of an explanation. I just want to break the ice here. Okay, so let's just sort of do something cool and interesting. Now, the only thing I do want to show you before we get started with that is if you go to the help section at the top here and go to About Houdini, this will show you the version number. And I just want to show you what version number I am on. Now, this is not entirely relevant. If you are using an older version, most of what I'm going to show you should work correctly anyway. And I'm pretty sure future versions will also still work. Okay. Obviously, if they don't, we'll make some update to the course. But in general, the versioning is not as important as people tend to think, except for if you're looking for a specific feature, right? And in this fundamentals course, we're going to basically be covering mostly things that are across all versions. But there are a few things later on that we are going to cover that are new to Houdini 18. So if you have a version lower than 18, I would suggest that you install this. The apprentice version is free, so there really is no reason to not use at least some sort of version 18 or above. Okay, so yeah, just wanted to show you that. Okay, so let's get started and do something cool, and then, as I said, later on we're going to go into more depth about like what actually happened in here and what what nodes are, what these different panels are for. But let's just start with something cool. Now, on the very top left, under this Create tab, you're going to see a bunch of sort of geometry things that we can create, and we're going to just drop down a torus. Okay. Now we can left click on this and then move it around in our viewport, and then when we left click, that's where it's going to place the torus. But instead of left clicking anywhere, if we just hit enter, it's going to place it at the dead center. Okay, and that's what I want. Now also on the far left here, you see I click on this little arrow, which is essentially the select tool, because at first when we drop it down, it has the gizmo selected, and that'll let us move it around, right? But in this case, I'm not going to actually move it around. I'm going to leave it exactly where it is. And the select tool is going to be very relevant to a lot of what we're going to do now. So, sort of clicking away to that so that I can actually drag and deselect my torus. Okay. So we have a torus in the dead center of the scene. You'll see that when it's created this, there's also a node that has been created in this is called the network view. Okay. And as I said, we're going to go into much more detail about this later. And then at the top here, on the top right, there's this parameter sheet, which has all the different parameters for that selected torus. You can see that that's the object that it has selected. Okay. So these are kind of the main three parts of Houdini that we're going to be looking at, although there is a fourth one that we really are going to be using a lot, which I'll show you in future lessons. But these are sort of the panels that you'll get used to the most. Okay. Now, the next step we're going to do is we're going to create a sphere. So in the top here, we're going to just click on sphere. And then once again, we can hit enter, and it'll place it at the dead center. But before I click away with my gizmo, I can use this gizmo to actually position this sphere. Okay. And instead of doing it that way, if you wanted to, you could also just manually change these parameters to be whatever you want. Okay, so you can change the, maybe the height. You want it a height of 1 or 0.5 or whatever, and you can just enter those numbers in here, or we can drag this around in the viewport. Okay, now what I want to do is essentially position it just off to the side, so kind of above the rim of this torus instead of dead center. But I also want to reduce the size. Let's make this uniform scale over here, parameter 0.5, okay, so that we have a much smaller sphere, right? There are, in this gizmo, there are ways of scaling it as well. If we click and drag on, oh wait, that's the pivot. There's different ways of sort of like scaling in that, but we basically are not going to do any of that with the gizmo. In fact, you're almost never going to. The gizmo is tricky to use. I only ever really use it for positioning stuff. In Houdini, you're generally going to want to use parameters. Okay, so we've got our torus and then our sphere, which is positioned just slightly above the outer rim. Okay, and again, you'll see here it's created a node here called sphere object 1. And obviously when we select that node or object, the parameters show what that is. If we select our torus, the parameters show the parameters of the torus. Okay. Now, what we're going to do is something really cool. So with our select tool selected, we're going to deselect everything. Okay, that is very important. And then on the top right here in this shelf on the right, we're going to find a tab called viscous fluids. Okay, so it's next to particle fluids and oceans, so between those two. And what better way to break the ice than with lava? Okay, so we're going to turn this sphere into lava and then have that pour all over this torus, and then we'll also throw in a ground plane just for some visual interest. Okay, now you'll see there are two actual sort of lava tools over here. One is lava from object and the other is emit lava. Now really the only difference between these two is if we clicked lava from object, this is going to essentially make a finite amount of lava. Okay, so it's as though this sphere is a sphere of lava and then we just let it go. Okay, so it'll fall with gravity and do its thing, but that's just a certain amount of it. If we emit lava, what it does is it uses the sphere as kind of like an infinite source of lava. So as some lava falls away from it, it is replaced with more, and so it forms kind of like a stream of it. Okay, so that's the cooler one. So that's the one we're going to use. Now, with absolutely nothing selected, we're going to click the emit lava button, right? Now, the reason I say with nothing selected is because when you run shelf tools in Houdini, they tend to ask you a bunch of questions so that it knows how to set that effect up for you. And you'll see here with my cursor in the viewport at the bottom, you'll see this blue writing that says select object to emit lava from, press enter to continue. Okay. Now, if we had something already selected when we clicked the button, it would skip this question because it would assume that the object that I have selected is the one that I want to emit lava from. So that is a way of obviously shortcutting it if you know that that's what's going to happen. But I would recommend not doing that and always just starting with nothing selected, because sometimes it's asking you for multiple objects. Like it will ask you for an object to emit from, but then maybe an object to use as a collider. And you're not really sure which question is going to come up first. So it's always better to just read what it wants, then give it the actual answer to that question. Okay. So we're going to click on our sphere, or you can select the sphere in the network view. But when you press enter to continue, you must do it with your cursor over the viewport, okay, not the network view. If you hit enter over here, you're going to go into a node. Whereas over the viewport where the question is, okay, so that's kind of an easy way to remember it, is that where it's asking you the question inside of this view is where we need to hit enter. Okay, so there we go. We can press enter and we're going to turn that into lava, right? But it's asked a second question. Select fluid object to emit lava into, if any. Okay, now what this is basically asking us is there already a fluid object that exists? Maybe you already have a whole river of lava, and so you want those two to be related, but this is just a source to add to that fluid. Okay, so that's why it says if any. The answer to that is we don't have any. Okay, we want to create one from scratch, so we can just, with nothing selected, hit enter again. Okay, and now it's going to think for a little bit, and now we have lava. Now, admittedly, This doesn't look very lava-like at the moment, but don't worry, we're going to get there. So you'll see here in the viewport, things have changed a little bit. Also, the network view has changed quite a bit. So this is, it's quite confusing. But so what it's done is it's placed a bunch of nodes for us, and it's actually, we've dived inside of a node. Okay, so I'll talk about that just now, but that's why the view has sort of changed a little bit. Now, we have our gizmo selected, but we don't want to move this around, because what this would be doing is moving the fluid container around, and we don't really need to do that, okay? I'll explain more about fluid containers in future lessons, so for now, don't worry. So we're going to click the Select tool, okay, just so that we can clean up our viewport. Now, in the network view over here, you'll see all of these nodes that have been placed, and they've been placed in a really haphazard way, okay? This is just absolutely terrible. So let's fix that. So let's drag select in the network view next to these nodes so that nothing is selected. And then let's just hit L on our keyboard, okay? Which is laying out all the nodes, okay? So this is a little bit neater so we can actually see what's going on. Now, again, I'm not going to go into detail of what all of these are doing, but we will later on. So don't worry if you are wanting to sort of understand what those are. But for now, all I want us to do is select this object over here called flip object, okay, or the one that's named flip fluid object, okay, this one. With that selected, you'll see that there's a particle separation parameter, and we're going to just decrease this value a little bit to 0.05, okay. If your computer is very slow, like if you're working at home on a machine that maybe was not designed for doing 3D, you can maybe even just leave it at 0.1. Or if you want it to be even faster to calculate, you can take this value higher. Because the higher this value, the less resolution we have. Because the smaller the particle separation, the more particles there will be. Okay. So I've just increased mine a bit just so that it looks a little bit better. Obviously, if you've got an absolute monster machine at home, you're welcome to take this a bit smaller, but be careful. You could crash your scene if you take it too low. 0.02 is probably as low as I would ever consider taking it. And the higher resolution, obviously, the better it's going to look, but the slower it's going to be to calculate. So you really want to maybe just, for the testing purposes, we keep it relatively low, okay? And then we can increase the resolution later on. Okay, now, over here in this network view, I just want to show you how we kind of navigate a little bit, because we're needing to kind of now do that. If we middle click, you can see we can kind of drag ourselves around. Okay, so middle click translates. Left click is obviously just selecting nodes. Okay, and then we can also scroll in and out. Okay, so they use the scroll wheel, or you can right click to zoom in and out. Okay, now something else to navigate here is we're going sort of in and out of nodes. What you'll see is at the top here, it says OBJ, which is actually the root level of where all of our objects live. And we're going to discuss this in great detail later on. But inside of that object level is our AutoDOP network. That's what this node is called. Now you'll see that we don't see our torus and our sphere. They're nowhere in here, and that's because we're inside of this node and it has its own internal nodes. Okay. So if we click on OBJ, left click, it will take us up one level out of this node, okay? So you'll see here where we now have our AutoDOP network. You can see it there, but there's our sphere and there's our torus. And it's also created another node called particle fluid. And if we double click this, we can go inside. So again, I'll go into much more detail about what's happening here later, but for now you can just know that this is essentially importing the results of the simulation, and this AutoDOP network is our simulation node. Okay, so what it's doing here is it's taking those points and then it's kind of representing them in our viewport, right? But well, for render purposes. Now I'll explain what we're doing sort of later on. You'll understand more about why we're doing this, but just zoom in here and you'll see there's a color node. Okay, and we're just gonna, on the far right hand side, just click display, like so. Click this blue button, or you can click the blue eye at the top here. Okay, so that instead of displaying particles, it's going to actually display this sort of mesh, which is the result of the fluid. So it takes the particles and turns them into an actual sort of mesh that represents the liquid. Okay. Now, this color node is supposed to be representing the color of that fluid based on the temperature of our lava. Okay, and that temperature is coming from the simulation. But in our viewport, it looks completely white, and that's just because it's trying to represent the material. So on the right-hand side, there's this little sort of tab of tools, and these are all to do with how we're sort of visualizing things in our viewport. And all we need to do is there's a little display materials on objects button here. It's a square, well, a cube with a checker pattern on it, and we can just click that to deselect that. And now it should more accurately represent the color of our fluid in the viewport. Okay. So now we're going to go back up to OBJ level by clicking on OBJ, right? And we now want to click play essentially on our simulation to sort of see what's going to happen. Now at the bottom there's a timeline, right? And we can, on the left hand side, you can see there's a play button. There's also a play backwards button if you ever do want to do that. And then there's go to the first frame or the last frame. So if we just click play here and let it run for a few frames, so it's going to start running, and then now we can press stop. So you'll see what's happened is that this has poured that liquid, but it's gone straight through our torus. Okay, it's like this torus doesn't even exist. It's gone straight through that, and it's also gone straight through the ground. And this is not what we want. And another thing we can observe is that you can see at the top here it's whiter, but at the bottom it's starting to get more toward the yellows, and that's because the temperature of this liquid is cooling. Okay, so at least that part is working. But let's make this torus an actual collision object so that it interacts with our fluid. And then let's also add a ground plane. Now something you'll see here as well, there's these blue frames. It's kind of this blue bar over our timeline. And this is showing which frames have been essentially calculated and cached to memory. Okay. So when it's blue, it means I can actually scrub backwards and forwards and see the simulation, almost live, right? Whereas if I then move to a frame that was not blue, it has to kind of calculate up to that point, okay? And that's how simulations work, right? They rely on the information from the frame before them, so we can't just skip to a random frame. It has to calculate up to that point. If I jump to my end frame right now, we'd be sitting for a couple of minutes waiting for this to calculate everything up to that point. All right. So let's go to the first frame again, and then let's make this torus a collision object. Okay. So once again, I'm going to make sure I've got my select tool selected, drag select to make sure that nothing is selected, and then on the top here, I'm going to go to the tab called collisions, right? And then we're going to click static object. Now, what a static object is basically an object that it's going to affect things in the simulation, but it will not be affected by anything in the simulation, right? So think of it almost like making an indestructible collision object, right? So this thing is going to stop the lava, but the lava will not have any effect on the torus. It will not melt it or do anything like that or push it. It just is going to stay rigidly like static in our viewport. Okay. So it's asking here, select object for static object, and then press enter to accept selection. So I'm going to click our torus, and with our cursor over the viewport, I'm going to press enter. All right. Now you'll see jump to the gizmo tool, but really it hasn't changed anything over here in our network view. Okay, it hasn't added any other nodes. But if we dive inside our simulation node, our auto.network, you'll see that it has added 3 nodes over here. Okay, a static solver, a merge, and a torus object, which is a static object. I'll go into more detail about that later, but for now, let's just hit L on our keyboard again to get back to sort of a nice, neat layout. And so this torus is basically just a collision object now. Okay, so when we click play, you'll see that we get a different result. But this now interacts with the torus. Okay, And because it's slowing it down as well, you can kind of see the results of the cooling a little bit better. So you can even see here it's getting a little bit more yellow, right? So this is all great, but again, it's still falling infinitely down into nothing, and I don't really want that. I would like a floor to this simulation. So again, under our collisions tab, there's a ground plane tool, right? So make sure nothing's selected, and then click the ground plane. Now, ground plane is actually going to jump us back up to OBJ level. So we were inside of this node, but it automatically brings us out, because it's basically asking us to position this ground plane. Okay, and it's put it automatically at a value of 0, sort of a height of 0. So it's sitting on the origin on the grid. But with the gizmo selected, or if you want to, you can change it in the parameter, is we're going to just move this down a little bit. Okay, so there I'm going to drag and move it down, or if you want to, you can set a value of like negative 0.2 in your parameters, and that should do fine. And then we're just going to change to our select tool again. Okay, now obviously if we just drag select, we're not going to select nothing. We're going to select the actual ground plane object, but another way of deselecting everything is dragging in the empty area between nodes. Okay, so now we have that ground plane. Now that's not just a normal grid, it's actually an infinite collision plane. Okay, and so if we dive inside of our auto.network, you'll see that it's created this ground plane node and plugged it in over here. And this is essentially just like I say, an infinite collision ground at a certain height. Okay. So now if we click play again, we're going to see that our lava interacts with our torus, and when it goes over the edge, it interacts with the floor and will start kind of pooling. And now we can kind of see the real kind of awesomeness of this lava simulation, where the way that it moves, its sort of viscosity and thickness is based on temperature. So you'll see that at the root, at the source, it's white hot, and so it moves very sort of smooth and liquidy. But the more that it moves away from that source, and over time, as these particles age, they're getting colder and colder. And as they do, they tend to slow down. You can even see it over here, where at the sort of center here, there's whiter particles that are moving faster, and they almost seem to be catching up with these outer yellow and sort of orange particles, because these are now slowing down, but these have not slowed down. And so it kind of forms that like rolling look that you'd expect of lava, because this stuff slows down. There's hot liquid at the back, so it's kind of pushing up against and sort of forming this like almost like a pileup of particles. Okay, so I've let the simulation run for a while just so we can kind of see what the result is. And you'll see now we're looking at particles here, and our torus and sort of everything else. There seems to be like this ghosting happening. And that's because we are viewing with a sort of ghost other object. So you see on the top right of this viewport, there's this option here to ghost other objects, or we can show all objects. So that will then show everything. Because when it says ghost other objects, what it means is basically we're inside of the simulation node, the auto.network. So we will see everything that's inside of here not ghosted, but then all other objects in other nodes will be ghosted. So we can kind of get a sense of what's happening in the whole scene, but we're seeing an opaque version of what node we're in. Whereas show all objects is showing the opaque version of everything, no matter where we are in our network. And we can go the other way and say hide other objects, which means it's going to show us only what's in that network. And so you see our sphere is actually invisible now. It's not being displayed, but we can see the ground plane because it is a collision object in our simulation. We can see the torus because it's a collision object. And we can see the particles because that's what we're creating from the sphere. But the sphere itself is not actually in the simulation, and so it's invisible now. Okay, so I just wanted to sort of explain that. So let's go up a level. So we're now looking at all of this, and we can see our grid, and that's kind of getting in the way because we don't really want to see that So on the right hand side at the top here, you'll see it says display reference plane or ortho grid. Let's just click that to get rid of it. So now we can see our lava. Basically we can drag back, and if I click play now, you'll see that it runs over the edge of that torus onto the floor, and we can actually see this sort of cooling and getting more toward the yellows and oranges. And if we let it run for long enough, it's going to reach the kind of reds and blacks as well, because you see that that color ramp that we had goes from white to yellow to orange to red to black as a sort of a way of cooling this lava. Okay. So the cooler it gets, the color changes. And also you'll see in the simulation the viscosity changes. So in bits that get darker and darker, they move slower. You can actually see it on the right hand side here. There's this orange patch which is now moving a lot slower than the yellow bits on either side of it. Okay. And there we have a lava simulation, right? So I hope that this has helped you kind of break the ice of Houdini. Okay, we don't need to sort of, it's no longer a new program to you. Okay, you've already done a simulation, so there's no need to sort of be intimidated by it or sort of unsure of what's happening. You've already done your first simulation. Now we'll move on to kind of, learning the details of how to navigate and all the bits of how Houdini's working under the hood. But really, it's not as complicated as the sort of reputation it seems to have. Okay, it can be very complicated. There is a sort of a very high ceiling for Houdini, and that if you want to take it to a very complex level, you can code your own solvers and make it do amazing things. There's almost no upper limit to it. But it has this reputation of having a very sort of difficult barrier to entry, that the floor is very high as well, and it takes a lot to learn just to do basic things, and that's not true. As you've seen here, we've been able to, with just 3 shelf tools, create a whole lava simulation. Okay. Of course, we want to do more custom effects, and we are going to build on this knowledge, but it's really, really simple to get started in Houdini. And then the more we build on that, there's almost, the sky is really the limit. Okay, so I hope you enjoyed this, and I'll see you in the next lesson. Hello, everybody, and welcome. So we're going to get started learning Houdini. And the first thing we need to do is basically just learn how to navigate around our scene, right? So we're going to discuss the different kind of window panes and different tabs, as well as how to actually navigate around our geometry in our scene view. Okay. Now, with these kinds of things, learning the navigation, it tends to be just a lot of sort of very dry information that is not really going to stick in your mind very much. So we're going to cover just what we need to know for now, just the very basics that we will be using regularly. And then as we continue through this course, we will learn more and more when it is relevant. Okay. But we're going to start today with the most important kind of views and sort of tabs that we're going to be making use of all the time. Right. So if we start here at the top of the scene, right, we have a menu that we would sort of expect to see in most programs, right? So we have File, where we can sort of open and save our scenes, Edit, which has preferences if you want to mess around with those, and a really good help section as well at the end here. And to the right of that, we have this drop down. Now this over here is showing the desktops. These are basically the arrangement of all these little windows that we're looking at. And by default, it's going to start with build, but these are different arrangements for, let's say if we switch to look dev, you'll see that we have a whole completely different arrangement of windows that, are designed to help for look dev. Now, build is the one that we start with, and actually that's a really good one to start with because it's simple and also has already 3 of the 4 most important windows that we need. So I'd like you guys to start with this, but what we're going to do at the end, once I've sort of shown you how to move these around and recreate them, we're going to add the 4th one and then save that as our own desktop. Okay, so here you can sort of save desktops. It'll appear in this list and you can select that desktop whenever you'd like that arrangement. Okay, now just below that we have our shelf. And we've already discussed this a little bit in our icebreaker lesson. But basically, this is just a collection of pre-built tools that Houdini offers us to help us kind of, take some shortcuts. Some of them, like the cameras and lights, are things that we're going to continue to use. So they're sort of a convenience tool, something that even when we're very experienced, we're just using this as a time saver, right? But other things, like especially the more advanced effects, you'll generally find that these are almost here to help you learn that effect. But once you've learned it, the shelf tool really kind of takes a few it assumes a couple of things and sets it up in a way that is maybe not ideal for you and your exact scene. So generally they're best applied in a blank scene as a way to learn, and then you go and apply that information to your correct scene in the way that you would like it to be. So we're going to kind of use this as a combination of a way to learn, like a jumping off point, as well as then, like I say, maybe your lights and cameras and a couple of other things, like under the create and modify, we will maybe use more regularly as just a way of saving some time. Okay. Now, below that, we have 3 window panes. Okay, this larger one on the left, and then these 2 smaller ones on the right. And you'll see that they have different tabs. So these are all sort of different types of views. Like we can jump to our animation editor if we want to alter our curves. But what we're going to do is we're just going to start and discuss the 3 most important ones, which are actually the 3 that we're looking at right now, right? So we have our scene view, which is obviously very important because we need to see what our geometry looks like. We can't operate blind. We need to see what our scene looks like. Okay. And then to the right of that, we have our network view at the bottom here and our parameters. Okay. And these 2 will go hand in hand because the parameters that we're going to see here are going to be whatever node is selected. Okay. But also the scene view and the network view kind of go hand in hand because when we select geometry in our viewport, it will show as selected in our network view and vice versa. Okay. So we're going to start with the scene view and just kind of learn how to navigate some basic geometry, and then as we go you'll see kind of what is happening simultaneously in the network view and the parameters. All right, so let's just use our shelf to drop down some basic geometry just so we've got something to navigate around. So under the create tab, we're just going to drop down a box and a sphere and maybe a torus or something, just so you can see some different geometry, right? Now, at first in our scene view, we actually had our view tools selected. Right now you'll see I have a sort of an arrow cursor, but by default it was actually a little hand, and that is our way of navigating the scene. But by dropping down some geometry, it has changed that tool automatically to this gizmo, right? This handle, which is kind of like a multi-purpose tool. It lets us rotate and move and set the pivot and whatever, right? Now, on the left-hand side, you'll see here is a toolbar, and there's quite a few tools. Okay, now we'll go through some of the most important ones here, but at the bottom here, there's a little camera icon, and this is our view tool. So this is what by default we had before we had dropped down any geometry. And this is the tool that lets us actually move around the scene. Okay, so if we left click and drag, we rotate. Okay, so we tumble the view, and wherever we do left click is going to be the pivot, unless we're not pivoting around any actual geometry. Okay, so if we just clicked in empty space, it would just rotate around the center, but right now what it will do is actually rotate around the last sort of pivot point that it has set on the geometry. So now that I've rotated around this point on the torus, if I click into empty space, it's going to continue rotating around that point until I then go and pick a different point to rotate around by clicking on that piece of geometry. Okay. Middle click and drag lets us pan around our scene. Okay. And then right click, and when we move sort of left and right or up and down, zooms in and out. Okay, so it just dollies. Now, I actually find that you sometimes also want to use the scroll wheel, which also does zoom in and out, but you'll find that the scroll wheel, depending on the kind of the size of your scene and what you've framed on, eventually the scroll wheel almost seems to have kind of like diminishing returns. As we sort of zoom in, it almost like slows down and has very little effect. Okay, not at this moment. I can actually zoom right through this, but you'll find that occasionally the scroll wheel almost seems to get locked up, but right clicking will allow you to zoom out how you would expect to. All right, so it's a combination of left, middle, and right. And if you do forget these controls, at the bottom here, there is a reminder while we have our scene view, our view tool selected. It shows you here left tumbles, middle pans, right dollies. Okay. Now, if we have another tool selected, let's say our selection tool, so at the top here, this cursor, which lets us select geometry, right? Now, while we have another tool selected, if we hold spacebar, it sort of quick selects our view tool, lets us move around, and as soon as I let spacebar go, it goes back to whatever tool we had selected. So in this case, my select tool. So I can move and then select, move, and select, and that's just by holding spacebar and then letting it go, right? So you'll see very rarely do I actually ever click on this view tool and use it. More than anything, I use whatever tool I have available, my select or my handle, and then just use spacebar as a way to navigate. Okay. Now, before we move on from navigation, I just want to jump over to our network view and show you how to navigate in here, since it is a little bit related. Now, in the network view, you'll find that there is no toolbar on the side with a variety of different tools, because really all we need to do in here is essentially navigate and be able to select our nodes. Now, the nodes, if we left click or left click and drag, we can select them. So that's like having our select tool enabled, right? But if we middle click, we can move around. Right, and this is because obviously there is no way to kind of tumble or rotate in this 2D view. So left click is select, while middle click is just navigate, and right is going to zoom, as well as the scroll wheel. So it's kind of like a combination of the navigation tool over here, the view tool, and the select, because left click, which would rotate, has now just been swapped with select. Okay. So, and you'll see as we select nodes, the relevant geometry in our viewport also changes, and you'll see our parameter sheet changes to that individual object. Okay, so you can see here the translation values change depending on which object I have selected. Okay, so back to our viewport, right? Now, so we've discussed the select tool here a little bit, but there are some extra options. You'll see there's a tiny little arrow on the right hand side of this, and that means that there are extra options. So if we left click and hold, or if we right click on it, it will come up with the different options, right? And so there are different ways of selecting, like we can change to a lasso select or a brush picking. We can also choose whether dragging a selection will replace or will just add to our selection. So there's a couple of other options, but also above our select tool are sort of 3 different modes for selecting. Okay, the top one is essentially for selecting full objects. Now, what it means by an object, and we will go into this in a little bit more detail later, you'll probably understand it better when we discuss how Houdini actually works, but essentially when we talk about selecting an object, we mean the node, okay, like the entire node. So if all 3 of these were merged into one node, then when we select one, it would select all of them, okay? And so it doesn't matter if they're actually separated by some blank space. If they are inside of one node, they count as one geometry. At the moment, they are 3 individual objects because they are 3 individual nodes. And so this mode lets us select entire objects. Below that, this will allow us to select geometry. Now, if I select my torus and then click on this, it's going to now go into sort of a geometry selection mode that lets me drag and select polygons. Now what it's actually done on the right hand side, you'll see, is it has dived inside of the Torus object node. Okay, and now it's showing us here a different node called Torus. I will explain the relationship between this node and the node above it soon, and that's a very important part of Houdini to understand. But for now, just know that essentially when we go inside of the node, we are now working with the geometry, not the other object. So see, I can't select the other objects, and I can select the geometry of this. Okay, so that is our geometry select. And if we click here to go back to object select, you'll see it automatically jumps up one level again to the object mode. Okay. The third option here is for selecting dynamics. So this is if we had a simulation. Maybe, for example, our sphere, like we did before, we turn our sphere into lava. It's a source for lava. So the lava is an actual dynamics object. So if we wanted to select the lava itself, we would use this third option. But maybe the sphere itself is still in the scene. So it's a sphere and it's the source of the simulation. So then if I had object mode selected, I'd select the sphere, but dynamics mode would select the actual source. Okay, or the same thing, we used our torus as a collision object. If I wanted to select the original torus, we would do it with the first mode. If I wanted to select the actual collider inside of the dynamics network, then I'd use the third option. If that doesn't really make sense to you right now, don't worry, it will later on the more we work with dynamics, but I just wanted you to understand what these three different modes are. And you'll see there are additional options under these as well. So when we're selecting geometry, we can also specify maybe that we don't want to select cameras, even if they are in the viewport. We want to ignore cameras, or here, if I switch off geometry, then I can't select my geometry, but I would be able to select cameras and lights and bones and whatever else. Okay, so there are a few other options under here. For example, when we go to geometry selection, we can also specify whether we're selecting points or primitives or edges or whatever. All right. So, but we will go into that in more detail in future. Now, below our selection options is a few transformation tools. Okay, we've already discussed the handle tool, right? And with something selected, because you see, when we have nothing selected, if we switch to our handle, it kind of doesn't change because it really is asking us to select something before it can show us that handle. So once we have something selected, though, it will now display our handle, right? And so if I drag, I'm not actually selecting anything because I don't have the select tool in hand. I have the handle. And this handle is what gets selected automatically when we drop down geometry from the shelf, because it's kind of asking us to position this in space. Now it has translate and rotate in here, right? So we can kind of do, it's like a multi-function tool, but also you'll find that for basic geometry, it'll have this handle, but for custom geometry, maybe certain shelf tools will drop down something that has a custom handle, and that might have other sort of strange gizmos and things on it that we can click and drag, and it will maybe, so for example, when we extrude geometry, there will be a slider that's on this handle, so we can grab the slider, and as we move it, it changes the amount of inset and extrusion and whatever. All right. So the handle is kind of very, very multi-purpose, but if we want to do individual transformations, we can. So above that, there are the three that we'd expect to find. So the translate, so this is essentially the move tool. Okay. This lets us just move without rotating. We can switch to rotation. So then this will just rotate and we'll have no sort of translation. Also, you'll see here we can rotate around the basically rotate around our view center versus rotating around individual axes. And then we can also scale. Okay, and you'll see that on the sort of multi-select tool here, the scale was not an option. But we can right click and kind of change the options of this, so we could switch it into a scaling mode, but much easier because sometimes this multi-select tool is a little bit overwhelming. There's so much going on. It's easier when we want to scale to just switch to the actual scale tool. In the center, we are scaling uniform, right? It actually doesn't change our uniform scale though, it changes all three of the individual axes, okay? So just keep that in mind. And then we can also scale on a specific axis or on 2 axes at a time, okay? Right, so that's our basic transformation. And then below that we have some snapping options. So if we do want to snap to the grid or to other objects, we will use those. And then right at the bottom, a very useful tool, which we will be using in future, but I won't show you now because it gets a bit in depth, so we'll discuss it later, is how to create a flipbook. So this just literally does essentially it renders our viewport just with OpenGL. So it's essentially going to take a play blast of what we're looking at, but we can specify a number of frames or whatever. And then we can write that out as an image sequence. So if we want to just test what's happening in our simulation and maybe it's really slow, we would run this tool as a way to then be able to play it back in real time. Okay. Now, at the far top right of our scene view are 3 important buttons over here, right? And one thing you'll notice if you are coming from another 3D program, there is a tendency in most other programs, because modeling is quite important, especially as a first step, that there will be multiple scene views. So within the scene view, it's divided into 4, right? So on this top right button, if you want that, you can do that. So we can switch to our normal sort of 4 views over here, top, front, right, and then our perspective, right? And navigating will be exactly the same. It's just that it's individual views. Of course, we can't tumble in the orthographic views, but we can do so in our perspective. Having said that, we really very rarely use that in Houdini. Any modeling you're going to do in Houdini is generally going to be procedural modeling, and so it's more about your nodes and actually what the final result is. We very rarely are switching to this view so we can kind of make sure things align and whatever. So I honestly, in the 10 years of using Houdini, have not used a 4 view or anything. You tend to actually forget that this button's here, but just in case you're coming from another 3D program and maybe that's a little more comfortable to you, you at least know where it is. Okay. But next to that are 2 tools that we will use constantly. This over here is basically showing how we display other objects that we do not have selected, outside of our node network. At the moment we're on the root level, so nothing will change as we change these. But for example, at the top, we're saying to show all objects. So if I dive inside of my sphere object, you'll see that the other objects are still fully visible. If I switch to ghost other objects, then these 2 become semi-transparent. And then if I switch to hide other objects, then they disappear completely. So it's kind of like we work on the sphere in isolation. We go up there, we're going to the torus, and the others disappear. All right. So that we're going to switch between quite often, because sometimes we want to hide it, dive inside, and kind of keep it all isolated. But other times you need to see what's happening with the other nodes, right? And then to the left of that is how we display our geometry. So we can display wireframe, wireframe on the boxes, like the bounding boxes, or just actual wireframe, smooth shaded with wireframe. So if we want to see our geometry, so this is all really, we're going to use this quite often, but most of the time we use smooth shaded, either just smooth shaded or with the wireframe. So I generally tend to switch between these 2 most of the time. You can do this kind of a hidden line wireframe, which is sometimes convenient for doing play blasts, but otherwise we're generally going to stick to these bottom 2. Okay. Then just below that as well, you'll see over here we can change our view to a different type of view. So inside we're in a perspective view, and like we saw here where we have these 4 different views, we can switch this if we want to a top view or a front view or whatever. Okay. This is also where our UVs are. So if we want to see our UVs, it's not a separate tab. Okay, so if you're looking for it, it is still your scene view, but it's just under here. Okay, although most of the time we're just going to use our perspective. And then if we have a camera, we will be selecting it through here. What's also cool in Houdini is you can look through your lights as though they're cameras. So we can do that, but we also don't have any lights at the moment, so there's nothing in our list, but we would be able to look through them and actually move around and arrange the lights in that same way. And then on the right hand side, we have, these are essentially options for what we display in our viewport. Okay, on the left is more sort of these interactive tools, but on the right, this is kind of like what we want to visualize, and mostly it's things to assist us with working. Okay, so the top button over here, this will switch on and off our grid. Right? So sometimes it's convenient to see it, but other times it just becomes messy, so we can hide it. Right? Then below that as well, this is a very important tool, which is locking the camera or light view. As I said, we can look through our cameras or we can look through our lights. If we lock it, then as we move, essentially we move the camera with us. If it's unlocked and we're looking through the camera and we decide to maybe rotate, we will just jump out of the camera and jump back to normal perspective view and leave the camera behind. Okay? So that's quite of a cool way of, we jump into the light or something, lock it, and then we can move, and you'll see the light will actually readjust, and we can find the exact angle that our light should be, and then we unlock and move out, and we leave the light there. So that's quite a common technique in Houdini. And then below that, we have displays for our light settings, so how we actually display that in our viewport. For example, we can have no lighting in our viewport here, or we can have just the headlight, which means essentially wherever we are, the light is, okay, which generally tends to be quite nice and light in terms of like it's not very heavy. When we have a big heavy scene, displaying the lights properly as well, it becomes very heavy, so we will often use this as a way to work with our scene. But if we do want to see what's happening with our actual lights, we can switch to our normal lighting, or over here we have high quality lighting and then high quality lighting with shadows. Okay, so these are our options for how to display it. Now you'll see here nothing changed. That's because we don't have any lights in our scene at the moment. But later when we are working with lights and rendering, you'll see that as we switch to these, it's going to show sort of the lights in a different way. Okay. And then under that we can display our materials. Now we already used this in our icebreaker lesson. Sometimes displaying the materials is convenient, especially if it's reading a texture or whatever. It can be quite cool to see that in the viewport and can really help us. But it does tend to be quite heavy. And also, as you saw, if we have something like emission or whatever, then OpenGL doesn't really display that very well. So it just tends to be white and blown out. And so we will just switch that off in order to see our geometry, but without the materials visualized. Okay. Very often I have this disabled and only enable it when it is actually useful, but it is on by default, so just be aware of that. Then below that we have a few other options over here. These are all for really kind of giving us visualizers to help us with our geometry. So for example, if we want to see our points, especially if, in this case we've got just geometry, but if we had a particle system, so it's a bunch of loose points that are not attached to polygons, they sometimes are very difficult to see. And so switching on to visualize our points can be quite convenient, right? It's also another way of sort of seeing the amount of geometry we have without switching to our wireframe. Okay. Then we can also display our normals, which we'll go into more detail later about exactly what happens with the normals, but if we don't have any normals on our geometry, then Houdini will automatically create its own intrinsic vertex normals, which is what we're seeing here. But if we do go and create normals of our own, then they will display here as well, and they'll be blue arrows, right? So we have our normals. We also have velocities. So at the moment nothing's moving, but we can, if things were moving, we can switch this on and we would see a visualization of our velocity of our geometry. And we can switch on to display point numbers, which can be quite useful, polygon normals, and polygon numbers, right? So these are all going to help us essentially work with our geometry. Then these are kind of lesser used tools, so I'm just going to skip past them. But at the bottom here, this little kind of pin icon, which is the visualization tool. Now this we are going to use a lot, but it's very complicated. So for now, I'm not even going to go into it much, but just know that what it essentially is, if we right click, you'll see here, it's essentially just custom visualizers. So how here we saw our normals. Well, what if I want to display some other attribute that I've created on my geometry? And you'll find that in Houdini that is very common of a thing to do, is where we're working with a lot of custom attributes, custom values, and we want to see what those look like in our viewport. Maybe we want to display them as colors, or display them like these point numbers where there are little numbers attached to the geometry, or maybe we want to display it with actual markers like this. We can take all of our custom attributes and essentially visualize them in here. Okay, and then way at the bottom, probably one of the most important things to know is this is our display options. Okay, and the shortcut for this is D on the keyboard. But just note that if you're hovering over the viewport and you hit D, it's going to open up our display options. But if we hover over our network view and hit D, it's going to be different, because there are display options for this view as well. And in fact, a couple of other views will also have that same shortcut. So it can be nice and convenient because we can just switch using D here back and forward. But just be careful that you are hovering over the correct viewport and that you don't open up this one and wonder why this looks so weird and why you can't set, for example, your background. Now, talking about that, we're not going to go through all these options because really that would be really, really boring. But you can kind of look through them. A lot of them are self-explanatory. I mean, just showing whether our lighting is on or not is basically what's happening here when we switch lighting off. And you can tint your back faces if you want to see them more conveniently. In fact, I think this is on by default. I may have switched this off and saved defaults. So if you, let's say, make some changes here and you want to save it as that's your new default, there's just a Save as Default button at the bottom. So you can click that, and then that will become your new default, right? There's guides. The one thing I do change all the time, I don't like this origin gnomon just sitting there at the center. It really is distracting and annoying. I know where the center of the world is. I don't really need a constant reminder, so I like to switch that off. If you want to leave it on, you're welcome to. I think it is on by default, but you can switch it off, and I'm just going to say Save as Default. So now in future, I won't have that. Okay. The floating gnomon at the bottom, this one here, I like. That is very convenient because sometimes depending on how we've rotated, we need to know which axis we're looking at. But the origin one I really find just distracting. So there's a couple of other options here that you can kind of just look through and see. We will maybe use some of these in the future, but really these are just about how you're displaying your scene. So it's more of a matter of convenience for you. But under the background, this one is one that we're going to use quite often, these two. So over here is how we display our background. So right now we're in the light mode, but there is dark, so it just goes black, and the gray as well, which I don't know, the gray seems to disappear with the geometry, especially if we don't have any wireframes. So I don't really ever use the gray, but dark is often quite useful for seeing the geometry because it's high contrast. And then light, sometimes, depending on what we're doing with our geometry, sometimes light is easier. So you can switch between these two as needed. And if you prefer the dark by default, then you can just save that as a default. Also, if we have an environment light or something in our scene that is going to have come with its own kind of background, essentially, and we don't want to display that, then we can switch it off here. Okay, so with this off, it will always display dark in the background, even if we have an HDRI or something in the background. All right. Okay, so that's that. Oh, and this is actually good that this has popped up. If you're working with Windows, there will be this Houdini console that will appear sometimes, right? If there's any Python sort of text printed or warnings or things printed, then it will pop this Houdini console up and sort of show you that error. And please do not close this. I mean, you can, Houdini will run without it, but it's really convenient to be able to read any errors that do appear. So at the very least, just minimize it, okay? It sits there, it doesn't do any harm to have it, but if something is going wrong, maybe you click a shelf tool and for some reason it just doesn't do anything and you're wondering, well, what happened? Maybe it errored and it's given you an error and told you why. Well, just come to the console and see what it says. Okay, so this will sometimes help you debug things, so just minimize it instead of closing it. Okay. All right. Now that we know how to navigate and we know about our views over here, the last thing to look at just quickly is our timeline. So if we click and drag this, right, so we can move our current frame in our timeline back and forth. Now, we don't have any animation at the moment, so obviously nothing is changing, but by default our timeline is 240 frames and we can essentially drag back and forwards through this, or if I click play, you'll see it's going to play. But actually when we click play, look how fast it is moving, and that is because it's just displaying these frames as quick as it can calculate them. Underneath the play, stop, pause section over here, there is this sort of like a clock icon. And if we click that on, what it's saying is essentially, I want you to play the frames, but at real time, as close to real time as possible, instead of as quick as you possibly can. So when we click play, it will now restrict itself to actual real time. Okay. Obviously, if we have a simulation that is really heavy, it will not be playing at real time. It will be playing slower than real time. It'll do its best to try and be at least real time, but what it will not do is go faster than it. So this tends to be a very convenient button that we need to press. Okay. So as you've seen, there is play, there's stop, or we can click the play again to just pause, which is basically the same thing. There's no real difference between the stop and this pause button. We can also play backwards if we want to. And the shortcuts for these, by the way, are up on your keyboard will play forward, and if we hit up again, it will stop, and then down will play in reverse. And then you can either hit down again, or if you hit up, it will then sort of ping pong, so it switches back and forth, right? And then we can also skip to our first frame and our last frame with these two, okay? Or we can enter a number over here and jump to a very specific frame, okay? And we can move around in our timeline just by left clicking and dragging. On the bottom left, like the far bottom left, is our options for our timeline essentially. So what FPS are we at? So maybe we want to be at 25, and then you can choose your start and end frame. So maybe I only need 100 frames. Once we have made some changes, if we click apply here, it will then adjust my timeline accordingly. So now I'm playing, I've got 100 frames and it's at 25 FPS. Then also something really interesting, don't have it enabled all the time, but we will sometimes use this to check if we have subframes, is to look at our non-integer frame value. So with this on, when we move forward a frame, it is going to literally, so if we push a right on our keyboard, we can move in single frames. We're going to move in whole integers, so from 14 to 15. But we can switch this to non-integer, and we can actually drag to, like, frame 14.09, okay, which can be useful when we're testing simulations. Okay, and then here is our real-time playback, which you'll see here as I'm clicking it. It's enabling and disabling that button. So that's just a convenient shortcut for that. Okay, so there we are. That's our animation settings. Over here as well, we have the option of essentially saying whether we want to loop when we hit the end of our timeline, or play only once and stop at the end, or zigzag. Okay, so when we like for zigzag, for example, we'll go to the end and we'll then play backwards. Okay, and play once would stop at the end, and loop would hit the end and jump to the beginning. Okay, so we can loop, and then you see it will go to the end and then just loop. All right, so That's our basic settings over there. Also, we can drag our sort of a sub section of our timeline. Okay, so there's this range slider over here that we can drag smaller and we can drag backwards and forwards. And so you'll see these numbers on the bottom are showing this is our start frame, but this is the start of our range. And this is the end of our range, and this is the end of our actual full timeline. And then this is our current frame. Okay, so sometimes when we've got a really large timeline, maybe something like 1,000 frames, which also in here, if I make an adjustment to our total frames, then it actually does adjust it. So you'll see here as I drag our range huger, you'll see we there's all of our 1,000 frames, but we can set our range a much smaller section and just sort of work with this part of our timeline, and then we can move along. Okay, so there are these sort of two sections. And then on the right hand side, there are some very extremely useful tools that we're going to be using all the time. So when we get more into Houdini and understand exactly how it works, we're going to learn about how it kind of calculates data and does what we call cooking. Okay, so cooking is essentially calculating our live node network and then displaying and caching a single frame, right? But sometimes that can be a very heavy process, and we want to essentially tell it, okay, stop cooking. Like, let us just work with the nodes themselves, but don't display anything in the viewport here. So just freeze the viewport and let me go and adjust my settings and then say, okay, now go calculate everything. Because sometimes as you're adjusting settings, it gets really slow. You make one small tweak to this value and then it has to recalculate for like 5 minutes, and then you want to change another value and it has to recalculate for 5 minutes, and that's not convenient. So on the far bottom right over here, this drop down lets us essentially say auto update, which is every time we make an adjustment to a setting, it's going to recook everything. Or manual, which says freeze, like don't do anything. I'm just going to adjust numbers and then you can recook later. Okay. So over here, we can come and adjust where this box is and do whatever we want. And nothing's going to change in our viewport until we set back to auto update. Okay. And then the kind of halfway point between that is on mouse up. Okay. And that is if we, for example, are dragging a slider of any kind. Sometimes, because as we're dragging a slider, this value you see is changing constantly. And could you imagine if it had to recalculate, if it was even 10 seconds? Imagine 10 seconds every time this number changes. We'd be here all day. But if it on mouse up, if I'm dragging a slider, it does not adjust itself until I let go, and then it will take that. Whereas in auto update mode, you can see it adjusts in real time. Now that's fine if it can do it in real time, but when we're working with very big simulations, it's not going to be able to do that. And so as we're dragging, it's just going to take forever. Okay, so these are three very convenient options, and we're going to. I don't really tend to use on mouse up, but auto update and manual we will switch between all the time. And then there's also another button kind of similar to that on the left hand side, which is this. It's a little brain. Okay. And what the brain is doing is when we click it, it's disabling any simulations. So it's kind of like setting it into manual mode, but only for simulations. So here, if I adjust the scale of my Torus, I will still see a live update. Okay, everything will still be updating because it's on auto update. But if I move through my timeline, my simulations will all be frozen and none of them will calculate themselves. Okay, because simulations tend to be the heaviest thing in your scene most of the time. There's a way of sort of disabling simulation, especially we use it a lot to go and set keyframes. So I'll move backwards and forwards in my timeline, set a keyframe here, set a keyframe. Okay, now I think that all the keyframes are in the right place. I'll go back to the start and re-enable my simulation. Okay, so that's super convenient. And also if we have multiple simulations, which, okay, if this is confusing to you, don't worry too much right now. It'll make more sense later. But if we right click, we'll have a list of our different simulation networks and we can choose which one it is going to display, because when we have a simulation, it displays blue frames in our timeline to show which have been cooked. Okay, and essentially here we can choose which one to display. Okay, so there we have it. That is most of what you're going to need in order to navigate this scene, right? But as I said, there are currently 3 different window panes, and we're going to quickly take a look at those, and then we're going to add one and then save our own custom desktop. So you'll see here the left and right is divided up by this vertical sort of line, okay, this bar. And if we click it and drag, we can adjust the size. Okay, so we can readjust our viewports like that. There are also 2 arrows over here. Okay, so the one is pointing to the left, the one's pointing to the right. What that's essentially going to do is collapse the viewport one way or another. So if I collapse it that way, it essentially maximizes this, but this bar is still on the left hand side. Okay, so now if I click it, it will come back to where it was. And I could collapse it the other way and then bring this back. And then there's a kind of a textured sort of a square in the middle of that, which if I click it, swaps the 2. So it keeps the divider where it is, but actually swaps the 2 halves, right? And you'll find that also when it is collapsed, if we click that middle section, it also swaps them. So it just keeps it collapsed, but swaps which thing it actually displays. Okay. So these are just some convenient kind of tools for how to rearrange our desktop. And you'll see we can divide either left and right or top and bottom. So here, this is a division that is top and bottom. So if I collapse our parameters, or I can collapse the network view, and I can drag this up and down. Okay, so that's how we sort of work with our panes, and within each pane there are a few tabs, so we can have multiple like different views. I mean, we could even have a scene view in here. So if I come over here and click the plus, and you'll see I can add a different pane tab type. So I could come under viewers and add a scene view, and now I have 2 scene views in my scene, right? And this is not the same as creating there's like the split views. I could have a split view and I could have a separate view here, right? In fact, this one could even be split if we really wanted. Okay, so the scene view, it's an entirely separate and independent scene view, and you can even adjust your settings differently on each one. So you could be viewing the lighting in one way on this pane, and then the lighting another way in this one. Now, there are lots of tabs, there are lots of different window types, so we're not going to go through all of them. As we use them, you'll start to become familiar with them, right? But some of the sort of highlights, obviously our network view where we have our nodes. This is super important. Our parameter view, obviously very important because we need to be able to adjust the parameters of our nodes. Our scene view so that we're not working blind. Our render view when we want to render. And then one of the most important ones that isn't here, although I think I might have accidentally closed it. I think by default it is at the end here, is called Geometry Spreadsheet. Now that's the one that we're going to be adding into this view because it is vital. Okay, I don't even like it as a separate tab because what I want you to do, and please trust me on this, you need to have that displayed all the time. Especially if you're new to Houdini, it is going to be the thing that is going to teach you the most about Houdini and what is happening under the hood. In Houdini, attributes on geometry are probably the most important thing about it. It's the thing that makes it so powerful. And if we don't see it, then we don't get used to it, right? And the more we see it, then you start to understand it more, rely on it, and as soon as you do, you can use that to your advantage. So please trust me. So what we're going to do is we're going to take this scene view on the left hand side and we're going to split it top and bottom to create another panel. All right, so on the far top right there's a square. This will let us maximize our view if we want to, by the way. And then there's a little down arrow next to that. If we click that, it lets us do things like, for example, we can tear off that pane so it'll actually become a separate floating window, or we can close it. But what we're going to do is split the pane top and bottom. Okay, so when we click that, you'll see it creates another pane and creates another divider here, right? And on the bottom, it's created another scene view, but we don't want that. So what we can do, we could do like what we did before, just add plus and go and find our geometry spreadsheet. But because we know we don't actually want the scene view here anyway, we can right click on the scene view and just change it to a different type. Okay, so you could either add another one and then close this one, or in this case, I'm just going to right click and change it to our geometry spreadsheet. Okay, under the inspectors tab, you're going to find the geometry spreadsheet. Okay, left click on that and it will set our view to be the same as the geometry spreadsheet. And then we don't need to see it so huge the whole time, so we can drag it down a little bit and use just the bottom section here, but just the fact that we're seeing it is going to be really convenient. Okay, so you can arrange it however you want, but I prefer to just keep it at the bottom of my scene view like this, and then on the right hand side we're going to use our network view and our parameters. Although sometimes what you will see I will do, especially because I'm trying to show you, I'm working on my laptop here. I don't have dual screens and or a really big screen. So what I do, if you're sort of struggling, especially in a big node network where you've got loads of nodes to look at, sometimes this parameter view kind of gets in the way, but we do need to use it. So something I'll often do is I'll collapse it to get it out of the way, but it's there if I ever need to bring it back. Okay, so I get rid of it. But then with a node selected and our cursor over the network view, if we hit P on our keyboard, then it pops up just like a floating parameter view within our network view. And we can change what we're selected, and you'll see it readjusts itself. We can adjust the size of this window there we go, so we can readjust it, and then we can hit P and it will go away. And so often I'll actually just work this way. I'll select whatever node I want, and when I want to actually change a parameter, I'll hit P, adjust it, and then get rid of it. I say get rid of it because it tends to get in the way. This one's not too large, but if you have loads of parameters, it just ends up being huge and taking up sometimes the entire screen. So that's fine. I'll pop it up, make the adjustments, and then hit P, move to the next node, pop it up, make the adjustments. So sometimes I like to work this way, and so I'll sometimes, you'll see me do that, or I might even set this as my default desktop, because sometimes this, especially on a laptop, this just really is taking up so much space, and then it's a pain to have to try and click it to get rid of it every time. Okay, whereas hitting P on the keyboard is a lot easier. So I'm going to work this way, but you are welcome to keep this, and also if you've got dual screens, you can set things up your own way. Okay. So now I'm quite happy with my viewport, right? So we're going to save this as a desktop. So at the top here where it says build, we're going to just click that. We're going to then say save current desktop as, and then we can call this whatever we want. So let's call this fundamentals, right? So we'll name it after the course, and we'll just click save. So now you'll see it pops up saying, all right, we've saved your view. So when we click here, it's in our list, and it will now always be in our list. By default, when we open Houdini, it will still be in build mode though. But you can change that by coming under Edit, Preferences, and then we can just go to the first one, because all of these are linked. So just go to the first one, and what you'll find is there's a drop-down list here where you can switch backwards and forwards between all the different options. But in the very first one, General User Interface, is our startup in desktop. So it's saying which one do you want to start up in by default. And so we're just going to go to fundamentals and say, okay, this is what I want you to always open into. And then when we accept that, now if we opened a brand new Houdini, it would look like this. Okay. And you'll see in here in our viewport, because I went and set my background to dark and I said save as default, it will be dark as well. But if this has reverted itself to light, it's because you haven't saved it as default. So if you want to, you can go and switch it back and then say save as default. But just be careful, it saves everything. So if you've gone and maybe switched off your grid temporarily, but you actually prefer it to be there by default, when you click save as default, then when you revert, you see that your grid will not be there. So be careful what you do. Okay, set it up to display exactly how you want, and then save it as default. Okay, so there we are. That's essentially just the basics of how to navigate in our viewport, how to navigate the different panes, resize them, save them as your own desktop. And so I hope that was okay. Not too much information, but this is all vital. We're going to be using this, and basically from now moving forward, we're going to use everything we just spoke about. There is a lot more, as you can see. There's how do we navigate our animation view, our render view, the compositing view, there's so many. There's loads that aren't even displayed yet, but we will get to those in time. Okay, so thank you everyone, and I'll see you in the next lesson. Okay, so when you first transition to Houdini, especially if you're coming from another 3D program, you'll probably find that it's quite strange. It works so differently to what you'd expect that you start to find like, where is all the information, and how do I control this, and where should I be working? It's quite overwhelming because it is quite unique. And I remember when I transitioned into working in Houdini, it was quite difficult, to just do the most basic things until I figured out or sort of understood how Houdini is working under the hood, and then it makes so much more sense and is a lot easier to understand. So I want to sort of take a second now to just point out to you how it works, so that as we explore more of it, you can kind of look for these little signposts, and you'll start to hopefully put that together in a way that will help you with this transition a lot better than somebody who has to figure it out for themselves. All right, so let's take a look. Houdini basically has three main things that I think are almost like the foundation of what makes it unique, right? So we have nodes. So Houdini is essentially just a completely node-based program. Almost every single part of it is just based on nodes, right? Nodes within nodes, plugged into other nodes. Now, that's not unique to Houdini. There are other node-based programs, but it is important to note that it is completely node-based. So that changes the way we think about it or work with it, and you'll start to kind of see how that comes together, right? And especially if you're coming from a program that is not as node-based, then it certainly will, this will be quite tricky. Like I came from a Softimage background, and with that, even though there was a part of the program had nodes, it was still quite difficult to figure out that just literally everything is based on nodes. So this is going to be one of the most fundamental parts of understanding Houdini. And the reason for this is because, well, the reason why nodes are so powerful really is because of a hierarchy. Okay, there are nodes inside of other nodes. So there is a sort of a vertical hierarchy, and then there is also horizontal hierarchy. In other words, nodes plugged into other nodes, and sometimes you've got two nodes plugged into one, and then one node splits out into two different branches. So there is this kind of almost this system, this flow of information that we need to learn how to read and understand. Okay. Then parameters. So on those nodes are parameters. In other words, settings. What that node is doing something, performing a particular function, but to what sort of degree? How strong is that effect? What are we doing on that node, right? And parameters seem pretty obvious when it comes to nodes, and parameters are certainly not unique to Houdini, but the thing that makes parameters so powerful in Houdini is that they can accept bits of code. And I don't want to sort of put off anybody who is not into coding and maybe doesn't enjoy that sort of more logical side of it, but Houdini does have a lot of like very small little bits, bite-sized pieces of code, really. And we're going to learn some of this because it's sort of just an intrinsic part of Houdini. You can't get away from it. But you don't have to go down the route of learning a whole language. You don't have to learn Python to use Houdini, although it certainly does help. But what I'm talking about is there are little bits of, for example, there are variables. You just get local variables. So if you just know the sign for So for example, $F, like $sign and then capital F is frame number. So if you want to set the scale of your object based on the frame number instead of a static number, now you have, as your timeline progresses, so would the scale of that object. And all you need to know to do that is the phrase $F. That's it. So we're going to learn all these little local variables and a couple of small but very easy to use bits of code that can go inside of these parameters that turn it from being a static value into something that is procedural, okay? Something that is based on other bits of information. So that is incredibly powerful. And then obviously if you're into coding, if you really like doing that kind of stuff and can sort of follow that logical thought process, then that just becomes more and more powerful. If you want to take Houdini to its maximum, then learning how to code properly is kind of just the way to do it. And then both of these two, the nodes and then the parameters on those nodes, are essentially, their goal is to create a geometry, and on that geometry there is a thing called attributes. Okay, in other words, it is the data, the information that is stored on the geometry. The position of every point is an attribute, but that point also stores information like maybe color, or it stores a vector for its normals. So now it knows where its normals are. It will store UV information. All of these are attributes, these pieces of data that geometry stores and carries with it. But the really, really powerful thing in Houdini is the fact that all of this data is accessible to us, not only to read, but also to write. So we can alter those attributes manually. We can write code to do it, of course, but with just even normal nodes and basic variables will help us alter those attributes in a way that lets us have so much control over what is happening with our geometry. Okay, and we can create custom attributes and store those and then read those later on down the line, and then have our nodes look at those attributes and perform different functions depending on what our attributes are. So essentially this is almost like the blood inside of your body just flowing around and passing information or vital vital pieces to the next part as it moves through the node hierarchy. The attributes are what is essentially flowing through. Okay, and these three together form the basis of proceduralism, and this is the heart of Houdini. This is what makes Houdini so absolutely powerful and really, really flexible, is proceduralism. Now proceduralism, if you don't know, is essentially just it's implicit information. In other words, it's an effect, it's some kind of result that is based not on a static value but on other things. So let's say the color of an object is based on how close it is to another object. So when we bring it closer, it changes color. That is procedural, right? So we set up the rule, and we don't go and set the color. We don't make it red. But what we do is we set up a rule that says you should be blue when you're far away, but when you get closer to this other object, then you become redder until eventually you're this red. And we even set that distance threshold. How far should it be blue, and then how close must it get to the other object before it becomes red. Based on that rule, that information that we give it, these kind of parameters that we set, then the system calculates for us. And so we could simulate those two objects. So now we don't have to go frame by frame and go and change the color, because we know that the closer it gets, we want it to get red. We don't have to keyframe and animate that. We can just set the rule and let it simulate. And that is what proceduralism is. And you see, in mentioning proceduralism, I found it almost impossible to not mention simulation, because really the heart, with proceduralism at its heart, the result is simulation. Simulation is so powerful when based on proceduralism. You can basically not simulate without proceduralism, because simulation is a set of rules, but it is just over time. It is saying, okay, when this object comes close to this other object, it then needs to bounce off. So I'm going to change the velocity depending on how close it is to another object. That is how it creates a collider. So when we do a rigid body simulation and a ball bounces on the floor, that is essentially proceduralism plus time. So frame by frame, it is running a procedural calculation. And so this is essentially what Houdini is based on. Okay, the end result is that we want to simulate most things. Okay, no, we don't simulate every single thing in Houdini. Sometimes we stop at this proceduralism step, because we can actually build systems that look simulated, but they're actually just based on essentially just procedural system. But other times we want to take that a step further and have it solve data, so we put it through a simulation. But all of that would not be possible if it weren't for the fact that it has a hierarchy based on nodes, code in the parameters, and the data that gets passed through attributes. And this is how Houdini works. Okay. Now, I know that some of this will hopefully have made some sense to you, but whichever parts of it haven't, don't worry about that. We will just hold on to this information, or try and remember this, maybe write this diagram down. And as we move through, because what we're going to do now over the next few lessons is we're going to go through each one of these in turn. I'm going to show you how it works in Houdini, and also explain the controls of how to, for example, work with nodes. And then when we get to parameters, we'll learn how to, alter and change our parameters. And as we go through, hopefully what I've just explained will make even more sense. Okay, so I hope this helps you. So the first thing we're going to start with is nodes. So let's take a look at what a node really is. So basically a node is a packet of data. Like it's essentially just performing a single task and then handing the result over to the next node in the sequence. Okay, so actually at the end of the day, really it's like running code. Okay, it's a snippet of code, and then there's it passes the result on to the next snippet of code. But the thing is, obviously not everybody is that into actual code, but nodes are basically a visual and very user-friendly way of running functions and codes. Okay, so you can almost think of it like a factory, where there's this machine that does something, and then it's kind of spits out the whatever, like the tin can, to the next machine, which then fills it up, and then the next machine pops the lid on. And so there's each one does a particular process and then moves it on to the next one. Right, so if we look in our scene, okay, so I'm in our fundamentals desktops that we created, and we have our network editor on the right. Now this is where all of our nodes live. Okay, and just to make sure, I'm going to explain what these are for you just now, but depending on what you may have clicked on, like for example, if you click on this motion effects tab, then it takes you automatically to the chops. So this, where it says CH over here, I'll explain what this all means for you later. But I know that there are ways to accidentally end up in the wrong network. So I just want to point out that if we click on that, left click on it, and go down to OBJ. So just make sure that you're in OBJ, and on the right hand side it says objects. Okay, so this is correct. And then we'll talk about what those channels, those different networks actually are in a minute. So in here, if we hit tab, and I mean, Houdini is kind enough to even tell us over here, press tab to add objects, right? So when we hit tab, it drops down a menu that has a bunch of categories that we can look through, and all of these that we're seeing here are potential nodes that we can drop down into our scene. Okay, so the way to add new nodes is hit tab, and then you can either go through these and find exactly what you're looking for, or we can start typing and then it will appear. So let's say we are looking for a geometry node. We type the word geo, and you'll see that what appears is an actual geometry node as well as a few test geometries. Okay, so in this case, just click on geometry, and then you'll see it kind of puts it in our cursor, but it hasn't dropped it down yet. We can then left click and it drops it down. Okay, so that's how we create a node. And you can, for interest's sake, kind of just go through here and look at what is available to us, and feel free to drop down things. We can drop down maybe a box as well. There we are. And so see how we've dropped down a box. That was very similar to creating a box through the shelf tool. And as I've said to you before, we are able to do everything manually that the shelf tool is kind of helping us do. Right. Now, while we're looking at these nodes over here, there's some things I want to point out. So one is that you'll actually see here, this one has a name Geo1. This one is called Box1, but it has this word geometry above it. Now, what that actually means is that this is the same as this. These two are both actually the same node. But this one has been named something different. So, because if it's called geo something, it then removes that extra name because it assumes that, well, we already know what it is. But if we had to rename this, something, then it puts the word geometry above that as a reminder that this is a geometry node. And so what's interesting is actually the box and this empty piece of geometry are the same. We're going to go into why that is sort of over time. You'll start to see what's inside of these defines how these are different to one another. Okay. Now, in order to rename this, you can literally just left click on the name and you can rename it whatever you want. So we can say whatever, right? Now, as far as I know, okay, they've taken it away. At some stage, you could actually name nodes with spaces in them. But then the code doesn't like to work with names that have spaces, so I think they took that away very quickly because there was like a version where it was allowed. Anyway, so you can name your nodes, but it's not going to change what the node type actually is. Then this is a geometry node. Okay. Something else that we should point out is that there is these sort of little circle at the top and a circle at the bottom. Okay. These are the sort of input and output of these nodes. And in Houdini, in most contexts, we will get to some contexts that don't follow this rule, but in the general contexts, it is a top-down program, okay, top-down node structure. So the output of this node would go into the input of another node, okay, and so it goes from the top down. We read down. Okay, almost like reading a book, right? You're just reading from the top down. And so essentially whatever is plugged in here is the parent of this node, and then whatever is plugged out from here would be the child of this node. Okay, and on this context, right, these objects on object level, right? You'll see we're in the object context. On this level, when we plug things in, what we're essentially doing is setting actual parenting. Okay, so in other words, if I move one object, so if I plug this, in fact, let me show you how to plug them in. So if we just left click on the circle, it kind of puts this connection into our hand, into our cursor, and then you see when we hover over here, it even says parent. So it's saying, okay, we can parent these nodes together, where this node is the parent of this. And that means that on here, if I hit P on my keyboard to pop up the parameter sheet, and now we have if I move now remember, this is an empty piece of geometry, okay? This was just an empty object that we dropped down. This one is an actual box that we're seeing. But if I, for example, maybe scale my empty object, the box scales with it because they're parented, right? If I click on my box, it still has a scale of 1, but why is it larger? Because its parent is larger, and so everything it does is based on its parent. Now if we disconnect this, so in order to disconnect nodes, we can right click on the actual connection. And sorry, my computer's a bit slow at the moment. If we right click on it, we can do a couple of things. We can insert a node, which if we do click that, it's going to pop up with the same tab menu and allow us to drop something down. So we can put down another geometry node, and you'd see that it kind of puts it in our hand, but you can see that the connection is between. So if I drop it down, it's going to essentially insert a node in between. We can remove a connection by right clicking and saying disconnect, and then it gets rid of that. And you'll see as soon as that connection was broken, this box went back to normal scale. And that is kind of what I was talking about before, where hierarchy of nodes is part of proceduralism, because this box's scale was procedural. Okay, it was not scaled up and now when we break the connection it's left at that size. No, it was sort of a live connection. So if we reconnect it, it goes big again, and then if we break this connection, it goes back to being small. Okay, so right click disconnect. We can also change and copy these wires, but these change the wire, so we can do that. But you can also just left click and move them. Okay, so when you left click and drag the connection, or if you left click and drag a little bit, then you can actually let go and it still keeps it in your hand, and you can just click to reconnect it there. Okay. Another quick tool as well is if we hold Y on our keyboard, then you see my cursor changes to these scissors, and we can just cut connections like that. Okay, and that's kind of cool because you could have multiple connections, and then with Y you can cut through all of them. Okay, so that's kind of a cool way of connecting and disconnecting. Also, let's say I connect this one to this. If I take my node and I drag it over this connection, you see even before I get there, it kind of magnets, and you can see it's trying to show us what it's going to do, is that it's going to insert it in between. So if I let go now, it inserts it in between, and now it's connected. And then another cool trick is to disconnect things, to disconnect nodes, including from in between, so where it's got something plugged into it and out of it. We can when you left click and move the node, and then we basically shake the node, and when we shake it, it loses its connection, and then you see it actually, whatever was plugged into it gets plugged into the node that was plugged out from it. Okay, so we can insert them, so now it's inserted, and we can shake it, and then it disconnects. Yeah, so it's also important to note that with these connections, you see how you can have multiple outputs. So one node can affect multiple nodes, and we could have more than this. So we can also, you can copy paste nodes, just so you know. So, and when you do, the connections stay copied, okay, or at least the inputs stay copied. So you'll see here, this is now connected to 3 different nodes. However, if I go to this node and try to plug it in here, it loses the connection to the first one, because these can only take a single input. Now some nodes will have multiple inputs, up to 4, or some can even have what's called a multi-input, which I'll show you. We'll look at that, one of those just now, where it can have loads of inputs, but it is node specific. So some will accept multiple inputs, some will not. And if it is just a single dot, it will be replaced. Okay. Right. So that's sort of, we know how to create nodes, we know how to delete them. Now let's talk about the flags. Okay, so on the left hand side and right hand side of this node are 2 sort of different colors. Okay? And also when we hover over this, there are a few buttons that appear in kind of like a circle around this node. And you'll see some nodes have more than others. So this one has 3, but you will come across some that have 5 or even more, right? And so these all allow us to kind of click and do something with them. The 2 colors are flags. Now, all the nodes will always have this eye on the left-hand side. If we click on that, it pops up an information sheet. Essentially, it's giving us information about that node, right? Now, there is another way to access that, which is if you just middle click and hold over a node, it shows us the information. Okay, so it gives us all sorts of things. It tells us the transformation, tells us the name, tells us what type of node it is, if it's time dependent or not, how long it took to calculate, when it was created. It's essentially just a bunch of metadata for that node. But the middle click method, if we let go of middle click, that box disappears. So that can be quite convenient when we're wanting to check some information like this. But if you want that information to stay up while we continue to work, then you can do that. So you can click I so that it does stay and you don't have to hold it. And then we can pin it if we want it to stay while we work and click on other things. Okay, and we could even pop up 2 information sheets and now compare the 2. Okay, and then we can obviously close those to get rid of them. So that information sheet will be available on pretty much every node. Okay. But then these other flags are unique depending on the context of the nodes. And we're going to talk about context in a second. But basically on these geometry nodes, we have 2. The blue one, which has got an eye icon here, is visibility. Okay, so if I click that, our node is now invisible in the viewport. Obviously, this was an empty geometry node to begin with, but our box, for example, has some geometry inside of it. Okay, so this is visible. But if I click the blue icon, it now disappears. Okay, so this is the visibility of this node and everything that is inside of it. This, on the left-hand side, is selectability. Okay, and also if we hover over these, you'll see it actually says there's selectable and display. Okay, also if you hover over the colors over here, right? So if we take selectability off, we can still see the node. But you see in the viewport here, no matter what I do, I can't essentially select it. I can't drag a box over it. Nothing I do will allow me to select that. But I can still select the node. So it doesn't make the node unselectable, just the viewport. Okay. So that's the 2 flags that we have on our geometry. But let's take a look inside of our box now, because I want to show you what's happening inside of here. Okay, so we've got all of these nodes. Doesn't matter if you stay connected or not. We're just going to go inside of our box. Now, see, inside of here is another node. Okay, this is basically inside of a geometry node is now we're in a different context, and this context is called SOP. Okay, so SOP, which means surface operators. And essentially what that is a list of nodes that define the geometry or the surface of an object, really. Okay, so this is the context we're going to probably work in the most, or at least equal to something like our dynamics operators, okay, which are called DOPs, right? So this is just your normal geometry context. So we can create geometry like here. This is creating a box. We can add points and parameters. We can manually build geometry and model things and edit. There's so much that we can do on this level. We can create volumes. Just basically, this is where you're going to work when you want to work with geometry. Okay. So, as I said to you, it's important to understand that this top level, although it's called box 1, could really be called whatever we want. This is just a container. This is not a box. Inside of it, there is a surface operator which creates a box. So this is the box. Okay, and if we deleted this or changed this to something else, then we still keep the shell, and even if it was called box, but we could drop down at something different in here. So for example, a sphere, and we could drop down a sphere, and now it's called box on the top, but it's a sphere. Right, so just this thing on the top is a shell, and this has information about the transformations of this object. So translation, rotate, scale, the pivot, all of that. It also has information about how this node should be rendered. No matter what geometry is inside of it, we're essentially it's saying how should this thing be rendered? What material is assigned to it? Is it visible in the renders or not? How should I sample velocity blur and things like that? It's essentially just information on what to do when this node is rendered, and a bunch of other information like switching onion skinning on or off, So this information is generic. it doesn't care what object it is. It just says everything inside of this gets handled this way. But when we're inside, these are the nodes that are determining what the geometry actually looks like, okay? And so let's discuss these SOPs. Now, the first thing we should have a look at is that if we hit tab, you'll see that now we have a lot more categories here to look through, and all these nodes are very different, right? So we won't find a geo node. If I type geo, that geometry node does not exist inside of here, okay? Because we're on a different level, we're in a different context, okay? So on object level, we can create a geometry node. Inside of geometry, we're now in a SOP context, okay, surface operator context, and so we have access to different nodes, and all of these nodes are to do with geometry and essentially working with it or altering its shape or the attributes on it. Okay, so you see here I created a sphere. We can also find, you know, torus and so there are a bunch of nodes that essentially create the primitives that we would want to maybe start working with. Okay, so we can drop down a torus as well. Now, you'll see that we can only see the sphere at the moment. And if on the far right hand side of this box where the display is, okay, if I click on that, we can now only see the box. And if I click here, we can only see the torus, right? So let's discuss what these flags are doing. And you'll see here that when I hover over it, there's more, right? So we have 4 flags, and we then have our node information, okay? So our information sheet. And even this sheet looks a little bit different because it's now telling us how many points we have, how many primitives and vertices and polygons that we have, all the attributes. So it says here point attributes, and we only have 1 at the moment. Tells us the bounding box information. So there's a lot of other things that this is telling us. Okay, so let's examine these flags. Now, the most important one to understand at first is this display and render, right? You see, if we hover over here, it says display/render. Okay, so these are actually 2 flags in one. And behind the node, you'll see that there are 2 circles, a blue circle and then a smaller purple circle. Okay. The blue is display. So the blue is saying what should be visible in our viewport. In other words, we can see the torus, and that's because this blue one is selected on the torus. Then the purple one is what should be rendered. So if I had to set up a camera now and render, I would render the torus. Okay, and these move together. So if I just left click, it moves them both together, but I can break them apart, and once they're broken, we can then move them independently. So if I hold Control and click, I move the render flag, not the display flag. Okay, and now that they're separated, if I left click, I will only move the display flag because it has been disconnected from the render flag. But if I do left click on the same one that has the render flag, they kind of glue themselves back together, and now when I left click, they move together. Okay, if you want to move the render flag, you always have to Control click. Okay, so once they're disconnected, if you left click will just move the display flag, but Control click will move the render flag. Okay, so now we can move them back together, and then if I Alt click, it specifically moves the display flag. Okay, so if they were together and I Alt, it will move the display flag, or if I Control, it will move the render flag. Okay, so in this current context, for example, we have the display flag on our torus and the render flag on our box. If I rendered now, it would render a box, but in my viewport, it looks like a torus. Okay. That might sound odd, and I don't know if you'd ever really want to do that, specifically, almost trick the user into rendering different things. But often what will happen is we'll have something like, the simple version of the torus is what we display, but maybe we're running a bunch of heavy nodes that do really complicated things to calculate the UVs and set up the materials and whatever, and create some complex thing that needs to be rendered. And so to keep our viewport light, we still just display the torus,
because it's kind of an like a proxy representation of what it would render like. But at render time, it then does the much more heavy calculations. Okay, so that's kind of the purpose of these nodes being separated. Okay, and if you don't understand that now, don't worry, we will use that a little bit more later on. Okay. Also, it's important to note that within one geometry node, there is only one display flag and one render flag. Okay, so we cannot have all of these objects displayed at the same time. If we want to have them displayed at the same time, then they need to be merged together. Okay, because this is a geometry node, that means it is one piece of geometry. So in order for these to be represented together, they need to be the same object. Okay. And there's a very useful node for this. If we just hit tab and type merge, there we can now drop down a merge node. Okay, now look at this node. This looks a little bit different. We have a sort of a line at the top instead of a circle. This input here is a multi-input. This is what I was talking about earlier, where this can take as many inputs as we would like. So we can click here and connect it there. And then when we click and connect something else, it just adds it next to it, right? Most inputs will only accept one, but this accepts as many as we want to give it, okay? And then if we move our display and render flag to the merge node, we can now see all our objects together in one scene, okay? Obviously, we're finding it difficult to see our box because it's inside there. If we hit, with hovering over the viewport, if we hit W, you'll see we go into wireframe mode and you can kind of see our box inside there. All right. So this is now displaying all three of our objects. And so they have been essentially merged together. And you'll see if we middle click, there will be more points and kind of primitive information than if we just middle click on here. So here we have 288 points, but on our merge, we have 297 points, okay? Because it has added all of this information together, okay? And you see how it kind of goes top down. So these nodes are all separate. They do a separate function. So this creates a torus, this creates a box, this creates a sphere. And then we take all the results of those different nodes and merge them together. And so this is now the result of that. And then whatever comes out here would be sort of all of this geometry. Okay. So for instance, I'm going to drop down a color node. Okay. So let's drop down color. Now, when I drop it down, you'll see it's actually got an error sign over here saying, you know, something's wrong, and that's because it requires some geometry to color. So let's put it down after our merge. Now, when we move to it, and if we hit P on the keyboard, we can now go and set a color for this. And actually, if we left click on color, it lets us go and pick a color. So let's go and make it red. Okay. So here we have red, and it has made everything red because it is after the merge. But let's now do something different. Let's shake this so that it disconnects, and then we'll move it here over our torus. So now we have a red torus, and when we shook it, the display and render flag moved with it. So we're currently only displaying the torus. Let's move our display and render flag back to the merge. And you'll see here that because the color is after the torus but before the merge, we now do not have a red sphere. And if we could see our box, in fact, maybe we should move our box. So if I just hit the parameters sheet here, we can change where the center point is. So let's just change that to 1 on X. So now we can see our box. You see that neither of these two have gone red because they have not gone through that process of being turned red, right? It's before the merge on only one of these streams. If I wanted, for example, my torus and my box and my sphere to be red, I would have to disconnect this, apply it afterwards, and display it. Change the display and render flag to that. And if, for example, we wanted to only color the torus and the box red and leave the sphere white, then there's a couple of ways we can do that, but one would be to just use a different merge node. So let's disconnect this, so we can right click and say disconnect, or you could use the Y and just cut it. So here we have one merge node that is merging these two and then making them red. After that, we can drop down another merge, plug in the color, and plug in the sphere, and move our display flag here. And see, so now we have two objects that we merge together. We then make those two red, and then afterwards we merge a separate object that has never been turned red. Okay, and you see how this hierarchy determines the result that we have here. And the really cool and powerful thing in Houdini is that it's fully procedural. Okay, so if we click on our color node now, it's alive, right? So if we change the color, it just automatically updates. Okay. Something also really cool is we can just rearrange the nodes at the top and we'll still receive the right result at the bottom. So we could take our sphere, shake it to disconnect, and let's take our box and also shake it and disconnect, and then we'll plug our sphere in here and our box in at the end. And now we have the sphere and the torus are green and the box is still white. So this whole thing is live and readjusts itself all the time. Okay, so that should hopefully help you understand the sort of render and display flag and how things can be adjusted that way. Now there is another flag that we should talk about, which is the disable flag. So this bypass, which is the yellow down arrow or the far left hand side. Okay, so this section disables a node. So if we go and disable the color, it's still plugged in correctly, but it just basically skips it. So when it goes to that point, it just skips and doesn't actually process anything inside of that node. If we disabled our sphere, for example, it would just disappear. There would be nothing. Okay. So also, if we disable our merge, by the way, what you'll see is that the first thing plugged into it kind of continues, but the other things plugged in just don't get merged. Okay, so you'll see that we end up with our torus, but our sphere does not ever get merged, and even the connection becomes a dotted line, and only the first one is a solid line. Okay, so that's our disable flag. Then on the bottom left, we have lock. So this would mean if we, let's say we click this, okay, it locks this node. And then if we went and changed this sphere, maybe we go and disable the sphere, you'll see that the sphere has not disappeared, because up to this point, this lock has essentially cached the information up to this point when we locked it. And it holds on to that information and will not allow it to be changed. So we could even go and disable our torus, or we can even unplug this completely and it will still be fine. Like, it basically remembers that information. Only when we unlock it, and it specifically asks us, do we want to discard the locked changes, then we say, okay, now it figures out that, hang on, something has changed, right? We can re-enable these. The thing is, locking is not very useful. I mean, there are very small uses for it, but do not get in the habit of relying on this. It's not the right way to work with Houdini. The whole point is things are meant to be live. Also, Houdini's scene files are very, very small. We're literally talking about kilobytes or just like a couple of megs, because they are all just a bunch of nodes. Everything is procedural and nothing is stored in the scene. But if you start locking things, then it has to store that information somewhere. And so your actual scene file, your HIP file, gets huge. So you really don't want to do this. And then, if you change things before then, and then when you do unlock, suddenly something doesn't work because you were relying on information that you have now lost. So I would not recommend using this feature very often at all. Okay. And then on the bottom right, this is a template. Okay. So what this does is it allows us to essentially display something, but almost as like a wireframe, just for reference, really. Okay. So let's say we want to come and work on our box, but we want to move this box around in relation to our torus and our sphere. So we might want to just see where they are. What we can do is over here, either on this little sort of icon at the bottom, or this kind of pink strip over there. If we click on that, it creates a wireframe version of that part of the node. okay, of the network. So if we did it just on our torus, we'd only see the torus, but after the merge, we then see that, okay? And so now we can reposition our box, and if we rendered, it would only render our box, but we can move them around relative to seeing where our torus and our sphere are, okay? Then you can also shift click to add other sort of nodes to the template, okay? So we could, for example, show the torus and then shift click on the pink strip on the sphere, and it'll now display both as a template, okay? And then we could shift click to deselect things from the template as well. So we can choose what to essentially display as a template. And then there is also control click. If we control click on the pink strip, it turns it into a selectable template, and you'll even see there's a slight difference in the color here. It's a little bit of like a darker pink color, almost a purplish sort of color, whereas this is like a light pink. When we do that, it becomes what's called a selectable template, okay? So you'll see here, it displays it in the viewport kind of as though it is merged with the box. But you see here, our display is set to the box. So if we rendered, it'll only render the box. We're displaying the box. But we can see the torus and even select it as though it has been merged, okay? This is a bit strange. Sometimes it can be a little bit confusing, and so again, I wouldn't really recommend using this too often, except for when you really just need to see the geometry displayed not as a wireframe. So if you are struggling with it, because maybe some objects as a wireframe get really confusing, especially if they've got lots of geometry, you might be a bit confused about where the edge is. You can't see that edge over there, whereas if we display it properly, we can kind of see how they intersect, right? So you might want to use it for that purpose, but then just be aware that while that is on, you can now select the pieces of that torus, which may not really be what you want. And especially here, it almost looks like, oh, okay, if I render, I'll render my box with my torus, but you won't. So be very aware of the difference between your display and render flag versus this selectable template. Okay. Right, so those are all the flags on the nodes, and also, oh, by the way, here you'll see little warnings. So our information sheet, if we click on it here, also displays any warnings or errors. So if something is actually broken, it's called an error, and then when it's just warning you that, okay, there's something that's maybe not as we'd expect it to be, but it's not going to break your scene, then it's called a warning, okay? And you can read what the warning says, and it will help you actually fix your scene. In this case, all it's really saying is there's a mismatch of attributes. That's because on the left-hand side here, we have color. On the right, we don't have any color attribute at all, and so it's just assuming that it's white. But that as soon as it needs to make an assumption, it's going to warn us and say, whoa, we don't really want to make that assumption, so maybe you should go and actually set the color of whatever is on the right-hand side here. So we could go and give them two different colors. That's not a problem. It doesn't care that they have two different colors, but the thing is, if it doesn't have any color on the right-hand side, then it just displays it as white automatically, and it doesn't really like doing that. Okay, so that's just what that error is. Okay. All right, so now that we've discussed the nodes like this, in the next lesson, what we're going to do is talk about sort of hierarchy and dependency of nodes, because that is a very important part of Houdini.
All right, so now that we understand a little bit about nodes and how they work in Houdini, we need to discuss contexts. So we'll notice when we created our geometry node in the previous lesson that there were different nodes available in this tab menu under the sort of OBJ area in our network view, right? So this is where we could create the geometry node, for example. But when we dove inside and we try to drop down geometry, you'll see that there is no such thing as a node just called geometry. So we are in a different context here, okay? Now, I briefly mentioned that this context inside of here is called SOPs, and on the top level is called OBJ, but we are going to sort of look at all the different contexts that we have available to us, just so that you understand. Now, I don't want to go into this in too great of detail because it can get a little confusing, and it is a topic that is better understood later on. But if I don't explain it now, then what we do with nodes might be a little bit confusing, and it might be strange that we can access certain nodes sometimes and not other times. So I'm going to briefly explain it now, and then the more we use this, it will make more sense later on. Okay, so let's just have a look at the list quickly. Now, besides OBJ for objects and then mat for materials, all the rest kind of follow this very silly sounding kind of nomenclature of so SOP is for surface operator, then you've got DOP, VOP, ROP, SHOP, and so on. Now, they all are just essentially operators with then a different prefix. And so this kind of gives you a clue as to what these contexts actually are or what they do. So very roughly, OBJ is for objects. Now that means entire pieces of geometry, no matter what they are. So whether it's physical, like sort of polygons and faces, or whether it's volumes or particle clouds, anything. Okay, so whatever the geometry is, pieces of geometry, as well as cameras, lights, just basically any object in our scene, right? So this is the sort of top level of our actual scene is OBJ. And then inside of any sort of objects that have a surface, like geometry nodes, for example, they would be inside of that. We then have SOP context, okay? And you'll even see here when I'm in our network view, when I'm on the top level, you'll see here it says objects, which gives us a clue as to what this is kind of about. Now, when we dive inside here, it is a little confusing. I wish they had sort of stuck with one consistent theme, and so maybe it should have said the word SOP over here, or surface operators or something like that. It doesn't, but it's kind of the same thing, really. Where it says geometry here, this is telling us that we are inside of geometry, and so we are working on surface level, so surface operators, right? And so when we hit tab, what we have available to us here are all of the nodes that are available in SOPs, okay? Then we also have DOP, which is anything to do with simulations. You saw in our icebreaker lesson that we dove inside of a dynamics operator, which was called an auto DOP network. So when we're inside of there, things look a little bit different as well. So I'll show you here. If we dive inside of a DOP, things plug in a little bit differently, and we have access to a whole bunch of different nodes. All of these are the different types of simulations and solvers and forces that you'd expect to see when we run dynamics. And so everything inside of there is, you'll see here it says the word dynamics on the top right of our network editor. And so all the nodes we find in here are DOPs, in other words, dynamic operators. Then we have VOP. This is VEX operators. Now, very, very briefly, we will discuss it a little bit more later, but briefly, basically, VEX is a shading language, but that has actually been kind of reappropriated to be able to operate on geometry and surfaces as well. So within SOP context, we can create what are called VOPs. And what they essentially are doing is just altering the data or geometry in some kind of way. I like to describe VOPs kind of as maths nodes. So you can do any kind of calculation or maths or anything like that to your geometry using a VOP. Now, there are other nodes that allow you to type actual code, but VOP is more of a visual network that represents code. So this is generally a good starting point. You kind of can't use Houdini efficiently without knowing VOPs, but you don't have to learn the coding that goes into them. Although if you do, it enhances your abilities in Houdini even further. Okay, so we will be using VOPs quite a lot later in this course because they are intrinsic to Houdini. But we will only very briefly touch on the actual coding that goes into it, just as a starting point for anyone who is interested in learning more about them. Okay, so you can use, you will find VOPs in actual shading language as well. So when we're working with shaders and that, you will use VOPs, but and very similar nodes will be shared across VOPs and then shops, which are basically built on the same language. But specifically VOPs, like I showed you now, are used to alter geometry because, like I said, it's a shading language which was called CVEX, but that has kind of been reappropriated to work on surfaces. Okay. Then we have ROPs, which are render operators. Okay, so this will be whenever we want to actually render out our scene. All the settings for our renders will also be a node. Okay, I said to you in the last lesson that almost everything in Houdini is node based. So even the settings for how we are rendering our scene are not just in some kind of sheet somewhere or in a window pane somewhere. It's on a node. And that node stores all the information for how we should render our scene. And so that will be in a context called ROP. Then shop. This is our shading operators. So we can build our shaders and materials in here, right? And I will actually skip ahead a little bit here to show you matte. So shop and matte are very similar. In the early versions of Houdini, there used to only be shop, but then they recently brought in matte, which operates kind of similar, but there's a few differences. So it's tending away from shops. Shops are kind of being phased out, or at least put on the back burner, and matte is kind of the replacement to that. So we will, when we discuss rendering, we will go into detail. We'll actually probably build a shader in both, just so you can see how similar they are and how they differ. But essentially, this is just building our shaders. And like I said before, it's built on CVEX. So it'll be similar nodes to what we would find in VOPs. Then you also have chops, which are channel operators. And all a channel operator is really is if we have anything, like let's say I create a transform node over here. Instead of altering, let's say, our scale to a static value over here that I can drag a slider with, instead of doing that, we can run the value of this in with other nodes, and we can, so we could add some noise or some kind of shake or smoothing or whatever using chops. Okay, so it's a whole different kind of context that allows us to drive the value of parameters. Okay, so we will touch on that a little bit later on. Then there is COP, which is our compositing operators. So this is where we can actually read in images that either we have rendered or external images, and we can run a bunch of different nodes to do different operations to those. And we could actually, in Houdini, you can render and then composite an entire scene all within Houdini. Okay, and that would be using COPs, which are compositing operators. And then the two newest additions to Houdini are LOPs and TOPs. These are quite advanced. We won't be going into them in great detail in this course because this is very advanced and you need to know a lot about Houdini to really get this to work well. But they are essentially the lighting operators and task operators, which basically lighting operators, it's nodes that are set up to try and help with kind of like a USD and rendering things in a simpler kind of context without having to very manually like load in all the specific lighting setups and lighting rigs per scene. So this is using Solaris, which is new to Houdini from 18. Obviously, if you're watching this in the future, this may be old hat by then, but this at this point is something that's being phased in. And then TOPs are your task operators, which is basically just, it's another context where you can run basically bits of code or recursive kind of algorithms or functions that you want to do, but in kind of a multi-threaded way. It's a very, very powerful context, but requires you to really truly understand Houdini. So it's about optimizing your scenes so that they cook in a way that is multi-threaded and can actually be possibly even distributed across multiple machines, right? So some of these are much simpler and we're going to use a lot more often. Some of them are a bit more complicated and we won't really be going into. Now, you don't need to memorize this list, but I just brought it up here so that you can maybe refer back to this lesson if ever you're confused about what a particular context is. Okay. Now, these contexts, we can access them in a lot of different ways. As you've seen here in OBJ level, if we create a geometry node and go inside, we then find ourselves at SOP level, okay? But there's a variety of different ways to get to all of these contexts. Some of them are not just freely accessible through OBJ, right? So one of the ways of accessing some of these different operators is through the networks. So if we click on OBJ at the top here, you'll see that there are a list of different networks, okay? So these networks are, there's not an equivalent one for every single type of operation, but most of them are at least here. Now, the one thing that is a little bit confusing, and it is a bit frustrating, especially when you're new to Houdini, that there doesn't seem to be that direct of a correlation between the name of the network and then the type of operators that exist within it. So once again, it would have been nice if they had named it consistently, but unfortunately they did not. So for example, OBJ, that's quite nice because it aligns with the name of our context here. So it's object level, which is OBJ, okay? That's fine. But the problem is something like CH is for chops, okay? They didn't call it chop, they called it CH, right? But channel, which is our motion effects networks, again, why that's a different name to this, I don't know, it's a little confusing. But eventually you get used to the fact that CH is chop, which is your motion effects, okay? IMG is image, right? Like, so, images, it's your compositing networks, so it's your COPs. Okay, so if you wanted to do any compositing in Houdini, you could come to IMG, and go inside of here, and this is where you'd find your compositing operators, right? So you can do everything that you would be able to do in a normal sort of compositing program, you can do in here. Load in an image, change the color correction, everything, reformat your images, right? So just think of that as image, and obviously you composite images. So that kind of makes sense, but would have made more sense if they made it the same name. Then matte, which, like I said, this is kind of newish. So matte is for your materials, but you'll see here it calls this Vex builder, because really the material network is essentially using CVex. So it is a Vex operator kind of level, whereas the shading network, so shops, is kind of, you need to go one level deeper to reach the Vex. So you'll see how that works just now. So there's our OBJ. So at least this we're used to seeing. Then out is our ROPS. So the out is where we would have our render operators. So for example, the default renderer in Houdini is called mantra. If we want to render anything in our scene, we need a mantra node, and this node will have all of the settings for our render. And if we wanted to maybe render multiple passes, you'd then have a different mantra node for every pass. And then you can select all your nodes and send them off to a render farm or have them render locally. And that's how you manage your different renders. Okay, so in out is where your ROPs are stored. Okay, again, it's very frustrating that they're not named exactly the same, but there's nothing we can do except kind of just learn these. Okay. Then shop, this is where your shaders go. As I said, you essentially would create shader nodes, and when you go inside of the shader node, then you'd be at Vex level, which is basically like being in matte. So there is a correlation between matte and shop. Shop is a little older, matte is the new way of doing things. I will show you this later when we get to actually rendering. Then stage is, you'll see here when I jump to stage, it shows Solaris over here, and it's actually gone and changed my whole view, my whole network view over there. So that's just a little bit annoying, but basically that is your LOPs. Okay, so here the LOPs, the lighting operators, would be if you go to stage. Okay, and then tasks, this over here is your tops. Okay. And you can see when we go to tasks, it actually says here top net. And then when we dive inside, now this is where we can drop down our top nodes. Okay, so you'll see in all these different contexts, when I hit tab, there are a different basically collection of nodes available. All right. So just left clicking and then left clicking on whichever context you want to move to helps us switch between these, but always just keep in mind which context you're in. Look at the top here where you are. Okay. And also on the top right, it does give you an indication of what level you're on. So we go inside of geometry, then we are on geometry level, which is geometry is SOPs. Okay. So that is one way that we can access this. Now, I just want to make something very clear, these contexts, because they can get a little bit confusing, but really what they are is it's just folders that have certain nodes that work together, okay? It would get very confusing if you had all of your geometry nodes on the same, like in the same network as all of your compositing nodes. Right? Because your geometry is creating the geometry that then needs to get rendered into an image, which then gets composited. So why would you want on one level to have your geometry and your actual renders? Okay, would really get very confusing and hard to manage and very untidy. So this here is just a way to keep things neat and understandable. Okay, but the cool thing with Houdini is that you can customize pretty much everything. And so there are a bunch of things, basically mobile networks on almost every context. So, for example, we're in object level over here, but I can drop down a DOP network, which is DOP there. Okay, so we can drop down DOP and dive inside, and now we're in DOPs. But on SOP level, I can also drop down a DOP network, and so dive inside there, and now we're inside of OBJ, inside of SOPs, inside of DOPs. And so here I can access my dynamics network, right? And besides actual like single nodes like that, there are also whole networks. So for example, let's say we have this object. Okay, so this over here, this is an object. So it's, it's a bunch of text and I want to render this. So I want to create a shader for this. Well, I can create this shader in shop context. So I go to the network, go to shop, and create a material for this. Okay, so I could create a material and build this material up and assign it to my my object over here. But something else we could do is on object level over here, if I wanted to, maybe I don't want to keep switching back to other networks, I can create a shop network. And then inside of this node, I can create a material. Okay, and then assign this to here. And what's even more than that is I can dive inside, and on geometry level, so on SOP level, I can go and drop down another shop network and dive inside of here and create a material. And I could assign this to the geometry. Okay. So this can be a little bit confusing, but don't worry about it too much. What it is flexibility. It's optional how you work. So you can choose whether to store your shaders for the geometry inside of the geometry itself. So let's say with this object, I wanted to copy this into my other scenes. Well, that would make a lot of sense if I maybe then included the material that goes with this geometry inside of the same node. Because now when I copy this to another scene, it brings the material with it. If instead I had several pieces of geometry on my object level and I wanted to assign them all to one shader or maybe a collection of shaders, then I could have a shop network on object level. And if I kept bringing different geometry in and out of my scene and wanted almost like a library of shaders saved with my scene instead of with the actual objects, then I would maybe save it over here. So you can choose exactly where and how to work. The more familiar you become with Houdini, the easier you'll find it to kind of switch in and out of these different contexts within different levels. But I just wanted to sort of show you this so that you can see it in a simple way before you get overwhelmed, because it can get really confusing. You can be inside of OBJ, inside of SOP level, and then inside of shops, and then inside of this we go in, and then we're in Vex. And then in here we can start dropping other things, we could look for like a SOP network or something. There's ways of essentially dropping down networks inside of networks inside of networks, and it can get a little bit overwhelming. But in general, we're not really going to work that way. We're going to keep things as simple as possible and close to the top level as we can. But over time, at least you know that Houdini gives you that flexibility when you understand what the different contexts are. Okay. Now, we do know how to actually switch between these contexts, and as I've shown you before, if we go inside and outside of nodes, we can basically use this top bar to navigate between networks, as well as when we're inside of nodes, we can go up levels by clicking at the top here. So you see this bar at the top is now filled with a whole path of where I actually am. And if we click on this node itself, then it will give us other options, okay, to see what's inside of it. But if we go click on one level up from the node we're inside, then we jump up a level, okay, and we can do that again. Or we can, right the way from the bottom level, could jump all the way to the top. Okay, so this is how you can navigate sort of in and out of contexts. And then I just want to sort of make it kind of clear to you how this, the fact that this path over here of where you are is very important to Houdini. And we're going to use that quite a lot, because sometimes we want maybe a particular operation, like when we want to assign a shader. How does this node know where to look for its shader? Well, we have to give it a path, okay? And that path comes in the sort of context the same as this, right? So it would be obj and then slash, you know, almost like you would navigate on your you know, on your computer, where you have, you know, maybe the root directory, and then slash, and then, you know, the folder slash another folder slash another folder. Okay, so this path over here would be obj slash contexts slash shopnet1 slash vop material1. Okay, and that's how we navigate. So we're going to use that quite a lot moving forward. So I just wanted to kind of point out the fact that it forms an actual path. Because, for example, if we wanted to navigate to a different material, which was somewhere in our shop network, then the path would be different. Instead of being slash obj slash whatever, it would now start with shop slash vop material1. So that would be the path to this material. Okay. Also, there is a backwards and forwards button over here. We can kind of go back and forward like you would kind of expect to be able to navigate. But we can always click here and start at the sort of top level of any one of these, and then start diving inside of nodes. And also, I just want to show you one quick shortcut that will make your life easier when working with nodes and networks, is sort of diving in and out using your keyboard, right? So you'll see sometimes I kind of end up just diving in and out without clicking at the top here. What I'm using is, so I jumps in to a node, okay? So I jumps in, and then U jumps up a level, okay? It's a little bit annoying that it's not I and O, okay? O brings up kind of a map of the sort of node network, so it helps you kind of see what you're working with. Especially if you've got a lot of nodes, this can be really useful. So O is almost like this weird map. I wish it was I and O, because that would be in and out, but it's not. So I is for in, but U is for up. So we go up levels and we go into nodes. Okay, but with the node it goes into will be the one that we have selected. So you have to kind of make sure you select the right one to go into it. And you'll find that you can't go into every node. Okay, so double clicking or clicking I on a node, on this font node, for example, doesn't work. Okay, that doesn't do anything, because that node has nothing on the inside, right? Or at least some nodes do, but they are locked. They basically have you know, hidden kind of black box coding, right? Same as our merge, we can't go inside, but this one we can. Okay, so you can always just try double clicking on nodes or clicking I to see which ones we can go into and which ones we can't. Okay. Anyway, so I hope this helps. When it comes to nodes and with these contexts as well, this is one of the sort of the biggest hurdles to get used to with Houdini. So it can be a little bit confusing at first. Do not worry if you are a bit confused right now. I needed to sort of explain all of this to you before we get going, so it at least makes sense a little bit, but really it will make a lot more sense when we actually use it and physically start making effects using these nodes. So try to absorb as much of this as you can, but if you don't absorb it all, don't worry. You can always move on. We'll start to work with the nodes and networks, and then you can come back to this if you want to refresh your knowledge of what these contexts are. Okay. All right, so I hope that has helped, and I'll see you in the next lesson. Hello, everyone. All right, so now that we know how nodes work in Houdini, we're going to be moving on to the next part of how Houdini works, which is the parameters. Okay. So as we've discussed before, on nodes, we have essentially a list of parameters. So nodes themselves kind of are there to kind of run internal operations. So they perform a function, but that function is controlled on the top level of that node by parameters. So you can essentially think of parameters like, I mean, you know, we've used driving a car as an analogy before in, with Houdini, and this is a good kind of use of that again. The parameters would be like the steering wheel, the pedals, just everything that you kind of have available to you, all these controls that allow you to determine how that vehicle moves, okay? How it moves, but also how, you can move your seat backwards and forwards. And so essentially you can adjust whatever it is that you want that kind of node to do, and how the sort of the results that you want out of that function based on the controls of these parameters. Okay. So parameters come in a whole variety of different types. Okay, sometimes you'll see they are just a single number, like our uniform scale over here is a single number with a slider. We have vectors, which are 3 different values, or sometimes you'll have 2, or maybe even sometimes more. Some of them are drop-down menus, like on here we've got our transform order and our rotation order are 2 different drop-down menus. There are toggle boxes. So there's a lot of different types of parameters that we have available to us, okay? Now, for the most part, most nodes have a label, okay? So, for example, here, translate, and you see when I hover over it, this is kind of highlighted. This is the label of this parameter. So these 3 are all called translate. The 3 of these all added together form the single translate parameter. But one important thing to note is sometimes you'll find that there isn't a label. In this case, for example, we've got transform order, which is the label for this drop-down menu. But this drop-down menu actually doesn't have a label. If it did, it would be squeezed here in between these 2, right? So labels can be switched off. Sometimes it's just for kind of visual purposes, keeping things neat, or sometimes they decide that a drop-down, like a label, is not really necessary. For example, over here, this drop-down menu does not have a label, but every parameter will have a name. Now, this is not really important at this stage, but I just thought I should mention it in case it becomes relevant to you later on. Labels are what we can read. Labels are for humans, right? So think of it like a label on your t-shirt. There's a label that you can kind of read and figure out information about that t-shirt, like what brand it is and what size it is, okay? So the label is deliberately there so that we can read it. So the label of this is called uniform scale. But the name of the parameter, if I hover over this, you'll see here in this, it says uniform scale, and then it says parameter : scale. That word scale there, all lowercase, no spaces, that is the name of this parameter. So if ever we reference this parameter using code, using any kind of script, it will use the word scale, not uniform scale. Labels can have capital letters, they can have spaces, I think they can even have some special characters, but names are very controlled. They have to have underscores and lowercase. Well, you can have uppercase letters, but actually that's kind of bad practice. You should generally stick to all lowercase. This is essentially a way of making it easy for scripts to reference it. Now, as I've said before, coding is so intrinsic to Houdini that actually later on it's almost impossible to avoid it. But I don't want you to be afraid of that, because there is a very low level sort of form of coding that you need in order to use Houdini. And it is so basic and so easy to understand that even if coding really is not your thing, You don't need to be put off. You don't actually have to even type it. I'm going to show you just now. We're going to use a trick to create code, but just using tools instead of actually having to type it ourselves. But when we even do that, you will see that code will always reference the name of a parameter and not the label. So that is one important distinction to make here when we talk about parameters. Now, these parameters, some of them are going to be numbers. Others will be text. I mean, for example, here this drop-down menu is asking us to select an option, right? So this is text for us, but the option will actually be represented as a number. There are some which are actually just lines of text. So under the render tab here, my materials, for example, is a path to a material. So I can start typing a path and it will allow me to navigate through my scene and select a node or a parameter or whatever I want, and this will come out as text. So I'm able to type in here. And also at the end of some parameters, you'll find that there are extra tools or buttons. For example, this over here jumps to this path. Okay, so if I've got a path and I want to actually go there, I can click this button. On the far right hand side, this opens a floating menu that allows me to kind of instead of having to type the path, I can actually go and select a path, right? And it particularly over here is trying to filter and looking for materials. So you'll see it's got our material and shop networks, but it will not let me navigate just to an object because an object is not a material, okay? So it's a specific menu that's designed to work with this parameter. So that you'll see is sometimes a thing. Also, you'll find that some parameters are disabled. Like over here, our display, you'll see this is grayed out and I can't activate it or do anything with it unless we enable this parameter over here, which this toggle on the left-hand side doesn't have a label, but it does have a name. So it is its own separate parameter. But this is essentially a way to enable the use of this parameter over here. And then I can set it. And you'll see here that even this, you'll see I can't set anything other than 0 or 1. It is a Boolean value, 0 or 1. So it's an integer, okay? Whereas if we go here to our transforms with uniform scale, I can set it to 0.444 or I can type whatever value I want. So even within numbers, there are some that are integers, some that are floats, okay? Then toggles as well are basically 0 and 1, so on and off. Text, we can just type. There are drop-down menus, so there are a wide variety of different types, okay? Now, when it comes to setting the values of parameters, there are a couple of ways. Of course, if there's a slider, it's very easy. We can just slide this backwards and forwards. We can also enter numbers, so we can highlight inside of a parameter and type a value, okay? So we can type 80 and then it'll accept 80. We can try type text, but then it's going to kind of do weird things, which we'll talk about this just now. So I'm going to just kind of break that and revert that to default. But, you know, in some ways, like in here, when we type text, it did not convert it to, you see, it didn't go green. Now you'll see green is actually keyframes. We'll talk about that in a little bit. But a string parameter like this, the material is expecting a string. So when we give it, when we type some text, it goes, okay, that's fine. But here, where it's expecting a number, if we type letters instead, if we type something other than numbers, it thinks we're trying to type some code, right? It's trying to do an expression, and so it's going to automatically convert it to an expression, right? Which may be what you want or maybe not. So just keep that in mind. We need to kind of enter the right type. Now, there is a really cool way of working with parameters and the values in Houdini, and so you'll see here the this one has a slide, a nice sliding value set, right? But what if we wanted to set this translate value and we wanted to kind of slide backwards and forwards instead of having to literally manually type it? Because maybe we want to see where we're translating this. So in fact, to show you that, I'm going to create a sphere inside of here. So this is just a SOP, which creates a sphere, just so that we can see where this is. And maybe I'll switch my grid back on so we can kind of see it moving around if I change the translate value. Okay, so if I set this to 1, it's going to move to 1. If I set this to 5, it'll move to 5. Okay. But sometimes you don't want to have to go and manually set that. So every time, what if we want to move it in very small increments till it, maybe the edge of it touches right over here? Well, then we have to go, okay, well, let me try 0.5. Is that enough? No, let me increase it 0.6. Okay, that's a little bit too far, 0.55, like that. That would not be a very good way to work with this, right? We want kind of just a slide like this, right? So if we hover over a parameter and we middle click and hold, it comes up with a value ladder over here. So by default, when we click, centered around our cursor will be 0.1. So this highlighted orange section will say 0.1 at the top, and then at the bottom it tells us the number that we have actually altered by. So what's going to happen, and I'm still holding middle click, if I move now, if I drag to the right hand side, we're going to increase in increments of 0.1. And if I drag to the left, it's going to increase in increments, or it's going to decrease, sorry, in increments of 0.1. And I can move up and down this ladder to choose what increments to move in. And once I've selected that increment, then when I drag, it will increase or decrease by that amount. So if I now start dragging to the right, you'll see that our sphere starts moving. And you can actually see over here, and you can kind of see it behind this ladder in the translate, but if it is hidden, it doesn't matter, because inside of this orange block, you can see at the bottom it says 0.0, which means that's how much I have increased it by, is none. But as I start dragging to the right, you'll see how much it is increasing it by. Okay, so there, it's now at 3.2. If I keep going to the left, I can go into the negative, right? Because I'm decreasing it by 0.1 each time, right? So let's say we increase it to there, and now it's like 3.2, and then I stop. Okay, when I let go, my cursor jumps back to where it was, and you could maybe increase this by a different increment, because maybe you find, okay, that's moving a little bit too fast or too slow. Well, maybe we're kind of close, but we want to get it to just touch the edge of another piece of geometry. So now we're closer, but we want it to move a bit slower so that we can be a little bit more precise. So we maybe zoom in and we try to maybe get it to touch the edge of this 5. Okay, so maybe we would say, well, let's increase it, get it a little bit closer. Now let's go in smaller increments. So I middle click and I move down to maybe 0.01. And I start increasing, and you'll see there it moves much slower. Okay, maybe that's a little bit too slow. So I could go to 0.01 and try and get it to just touch the edge of the 5, right? So see, this is a way of kind of choosing how fast or how slow to increase by. I mean, if we zoom out and see here, if I go up to 10 and move it, you see how very fast it moves there, because it literally is increasing and decreasing in increments of 10. Okay, so this is a very good way of adjusting numbers, so floats and integers. Obviously, this won't work on something like a string, because there is no ladder slider for that. Okay, but something that does happen with strings is if we hover over it and actually scroll up or down, if there is a number at the end, it actually increases or decreases that number as we slide. Okay. So that's kind of an interesting way. Not really that useful on strings, although sometimes you can use it. But you can also do the same here over parameters as well. So as you scroll, you'll see it's increasing by 0.1, increasing or decreasing, depending on which way I go. And you'll see if I hold shift, it increases and decreases by 0.01. And then control increases by 1. Okay. And let's see if alt Alt does nothing. Okay, so Alt is fine, but Control does it essentially faster, Shift does it slower, and then normal just kind of goes in 0.1. Okay, although the value, this ladder slider is a lot more useful because you have direct control over which one. Okay, right. So that's essentially how we would set normal values. But what about keyframes? What if we want this to move over time? Okay, so to set a keyframe, let's say we're happy with this where it is now on frame 1, but by the end of our timeline, we want it to be somewhere else. Okay, so if we right click on the parameter, now I just want to very clearly point out here, if you right click on the label of a parameter that has multiple values, like here, this vector, then it's going to alter all three. Okay. In fact, actually going back to our value ladder quickly, if we do it over that label, you'll see now it increases all three values by that amount. Okay, so it's increased them all by 4. So these are now set to exactly 4 because they were 0 first, but this used to be 2.283 and now it's 6.283. And it'll be the same with setting a keyframe. So if we want to key all of these, then we would right click on the word translate. If we want to key just the X value, then we can right click over this parameter. Okay, so just over the black box over here. Okay, so let's, in this case, let's key all three. So I'm going to right click on the word translate, and then we can go under keyframes over here. So there's a lot of options over here. Don't worry too much or get too overwhelmed. We will go through some of these. Some of them we'll find more useful than others. Under the keyframe section, there is set keyframe, and you'll see over here it actually shows you the short key is Alt and left mouse button. Okay, so we can click that, and you'll see it now goes green, which shows that it has a keyframe. And in our timeline, we have a green kind of little square over there over the first frame. And also when we're on the first frame, you'll see this little almost like speech bubble looking thing that shows us what our current frame is green. When we move away from it, that becomes white. And you can see there, that's our keyframe. Okay, so we can move, and then as soon as we go over on 1, it shows us that there's a keyframe. Also on the bottom right, there's a little key icon over here, and that also goes green when we're on top of a keyframe. All right. Now, when we move away from it, you'll see that these values over here become blue, which kind of shows that these parameters are keyed, but we are not on a keyframe. All right. So let's move to maybe somewhere in the middle, right? So we'll move to frame 120. And then we can maybe make some alterations here. So let's use our value slider just to get used to this ladder. So let's take our Y value up a little bit. Okay, so we'll kind of maybe increase that a little. Oh, and depending on what operating system you're on, you can keep scrolling beyond the edge of your screen and it'll actually loop all the way. So on Windows, it does this. I've found on Linux, depending on your settings, some do not allow that. It won't really allow you to go over the edge, so it does kind of strange things. I haven't tested it on Mac at all, so I can't really comment on what that will do. But on Windows, it does actually kind of loop all the way around, so you can just keep sliding. Okay. So let's increase it to there, and then let's take our X value and maybe set that, maybe decrease it. So let's set it there. Now you'll see both of these went this kind of, kind of greeny yellow, weird color. This means that the value has been changed, but it has not been set. It has not been committed to another keyframe. And you'll see in our timeline here, it's actually kind of more of an orange. And our button over here as well is an orange, right? And we can left click this to add a keyframe if we want on this frame. Or we could have just over our parameter, could have right clicked again and said set keyframe, okay? So there's a lot of ways to sort of commit that keyframe, right? Now, obviously by clicking this button over here though, what this is doing is adding a keyframe to all of the parameters that have keys, at all, because you see it added it to this 4 over here, even though this Z value wasn't changed, it still added a keyframe there. Okay, and so now you'll see if we slide backwards and forwards that this moves linearly from frame 1 to frame 120. Okay, and then as we move, you can see these values don't change. Okay, so that's how we set a keyframe. Now, what if we want to maybe remove a keyframe? So we decide, okay, well, actually, we don't really want it moving up and down on the y-axis, and actually, maybe we're fine here. So what we can do is, instead of removing all three, because maybe we're happy with our x and our z, but y we want to change. So let's right-click over y, and then under keyframes, we can... Oh, actually, sorry, it won't be under keyframes. It's over here is delete channels. Okay, and the shortcut for this is Control, Shift, and left mouse button. Okay, so we can hold Control, Shift, and left mouse button, or just click here, delete channels. Now the reason it's not under keyframes is actually because it doesn't only relate to keyframes. It is also used if we have expressions. So if we've typed an expression, kind of counts like a keyframe, we can delete the expression as well this way. And so that's why it's kind of in its own, kind of in the main menu. Right, so we can delete that. Now if we do, it keeps the value that we had. So it'll now, we can still animate left and right because our X value is still animated. But now we can, with our Y, maybe we want to reset this back to 0. Now, obviously in this case, it's very easy for us to set this to 0 because we can just select it and type 0. But what if you don't remember what it used to be? With translate and whatever, that's kind of easy. But maybe when we set a drop-down menu here, okay, we could maybe change this to bounding box. But now, how do we know what one it had by default? It's not always going to be the first one. In this case, it actually happens to be the first item in the menu, but it is not always the case, right? I'm trying to see if I can find one where it's not the first item in the menu. A lot of the times, just for convenience sake, it will be. But okay, here, for example, this is render unconnected points by default, but we could change it to no point rendering, which is the first one. Now I want to point out that we know that this is not the default value because you can see it highlighted, like, well, it's sort of bold, right? So that you can see it's bolder here, and when I set it here, it's still bold. And then when I change it to render unconnected points, it goes away from being bold. And that's because this is the default, but these others are non-default. Now, if this was a really long menu, we wouldn't want to literally have to switch backwards and forwards between every one looking for the one that isn't bold. So how do we revert it back to the value it should be if we wanted it to be default? Well, again, we can right click on here, and then near the bottom is revert to defaults, which is Control and middle mouse button. Okay, so you can use either the short key or that, and it will revert it back to what it used to be. And just one other thing to point out, you see when this went bold, so did the tab menu, and also this at the top here, you see the word render is bold. The whole kind of hierarchy of all the parameters that are not set to defaults will be bold. So right now we know just at a glance, even without being on that tab, you can see that, oh, something here has been changed. Which means this will help you sometimes if you've gone and maybe changed a setting and you're not sure where you changed it. Well, this will kind of help you navigate. So you go, oh, that's bold. Something here has been changed. What has been changed? Oh, I can see that's bold. So that's not default. And then if you go and set that to the default, which let's maybe just try Control middle mouse button so that it reverts. You'll see that reverts. But render is still bold because this parameter over here is not set to default. Okay, if we Control middle mouse button over that parameter, then render will go away because now everything inside this entire tab is set to default. Something else you can do though as well is actually set the whole tab to default. So let's say we've changed a whole bunch of different values. Okay, so let's just change a bunch of things. We can actually Control middle mouse button on the word render, and it actually goes and reverts everything back to the defaults inside of that whole tab. Okay, now you need to be careful with that. That's not advisable all the time. You need to know what you've done really. Okay, and also you need to be careful. What it will not do is get rid of keyframes. So you see here I reverted it, and it has kept these two as keyframes, but because I was on a keyframe, it has committed those two values as the new values for that keyframe, right? If I did it on when it's blue, so these are not at a keyframe, but they are in between two values, and went and set it, it'll set these values to 0, but it's kind of gone back to orange here where it says, okay, do you want to commit this as a keyframe? Now, if you don't, we can just move on. And as we move, it kind of reverts itself back to ignoring that value that we changed. But if we do want to, then we can make that 0. So control middle mouse button, and then again we can make these, we can keyframe these. Okay, so if we alt and left click, it's going to keyframe the whole parameter, and that might not be what we want. Okay, so we can undo that, control Z, but you can alt left click on each of these two parameters and separately add keyframes there without having to add a keyframe to Y, which maybe we don't want to do. Okay, so now you'll see it goes from there to 0 and then there, right? And then if you're on a keyframe, as I've said, you can then, if you make a change, it will automatically commit it straight away. So be careful if you're on your keyframes and you start changing values, then things are going to change. Okay. So we know how to set keyframes, and then we know how to delete the keyframes as well, which remember here is under delete channels, and then we know how to revert the values as well back to 0. Now, you saw how keyframes are green, but there are also expressions as well. And like I said, if we do type an expression, like if we just start typing some text over here, it goes green because it assumes that what we've done is that this is an expression. Even if what we have typed is absolute gibberish, it thinks that it's an expression, so it will change to green. Although the node itself actually throws up an error saying, whoa, I don't understand this code, right? That's understandable because we haven't really typed anything, but it comes up as a keyframe. So if we have our node selected, you'll see here we have a keyframe in our timeline and it looks green. And we can handle this the same. We can right click and say delete channels, and it will get rid of that absolute gibberish and just revert back to sort of a value. Because it wasn't able to read that as any value, it will revert to its default value. Okay. Now, talking about expressions, I'm going to show you a trick in Houdini, and this is something so important. This is something you're going to use 100 times a day if you use Houdini. It is so integral, it is used so commonly that it's just, it almost needs to become second nature to you, right? So this is worth learning and really memorizing how to do this, but it is easy, okay? So we're going to be using an expression here, but actually we're not going to type anything, okay? So don't worry if you have no idea or you really hate coding, that's fine. You don't need to do any coding at the moment, but we're going to essentially get Houdini to do the code for us. If we want one parameter to follow another one, so in other words, we just want to say, listen, the bigger you get, the bigger this, I scale this sphere up, then the more it should move along maybe the y-axis. Okay, so because I kind of maybe want it to inflate from the bottom up. So as I scale it up, I also want it to move up by the same amount, so it seems to kind of just increase in size and height at the same time. So I want to link this parameter to this parameter. So how we do that is we can simply, over our uniform scale, we right click, and then we say copy parameter, right? So just copy, right click, copy, but you can't just control C. If you control C a value, it will copy the text. So it copies the actual character 1. And that is fine if that's what you want. You can just select this text and control V, and it'll paste the value 1. But that's not really what we want. Okay, we want to copy the actual parameter. It's a Houdini copy instead of just, normal control C, control V. So we right click and say copy parameter. Now on this Y, when we right click, there are a few paste options. So one, we can paste the values, which is kind of what we just did, right? If it was 0 and we right click and say paste values, it's going to paste 1, okay? But what's cool there is even if this was maybe a keyframe, it won't copy and paste the keyframe, it'll only paste the value. So in fact, let's do that quickly. On our uniform scale, let's give it a keyframe. So I'm going to alt left click on the word uniform scale to set a keyframe. I'm going to go to frame 120, and I'm going to go and set this. I'm going to type the value 10, okay? And I'm going to commit this change by alt left clicking on uniform scale. So now we scale up over 120 frames. Okay. Now again, if I control copy my uniform scale, sorry, right click and copy, And then over Y over here, I right click and paste values. It's going to paste the value 1, but it's not animated. It doesn't take the keyframe. Okay. If I now say paste value, okay, well, sorry, I'd have to copy again. So copy and then paste value. It's going to paste the value 5.67013. Okay. But that's just a static value. It's not changing. Sometimes that is what you want. So it is cool that you can do that, right? So let's set this back to 0. But in this case, let's do something different. So right click. Now, something else we can do is paste expression or channels. So this keyframe, I know it's a little bit confusing, but in Houdini, keyframes count as an expression, right? So, and an expression, what I mean by that is just a small little line of code that says something. So even a normal keyframe is a line of code that essentially says on this frame, I should be this value, and then on that frame, I should be this other value. And then it also, in that code, tells it how to interpolate between those two frames. Is it linear? Is it a Bezier? If so, what are the slopes of each kind of point on that Bezier? This is kind of all the information that's in that code. And because it has to have all that information, that's why it counts as an expression. So when we say paste expression or channel, which remember channel is our chops, so that's another way of driving the value of a parameter. What it's going to do is essentially paste the keyframe. So now on both of these, they each have the same keyframes. So as it scales, it also increases on the Y value, right? And so it seems to kind of expand up from the bottom, right? Like blowing up a balloon, right? Now, we've pasted that channel, but they are not linked. It is just as though we went and did the exact same thing that we did on here to here. So they are now separate. So I could go and alter my value here on my keyframe, and it would not change this one. Okay, they are not linked, but they just had the same value, and now I can go and change it. So again, that may be what you want, but I'm going to now show you the really cool trick in Houdini, and this is something we're going to use all the time. So I'm going to Control Shift left click to get rid of that. And I'm going to Control middle click to clear that, okay, or to revert it back to defaults. Now instead, what I'm going to do, and it really doesn't matter what frame we're on when we do this, I can right click on uniform scale, copy our parameter. On Y, I'm going to right click, but now I'm going to say paste relative references. Okay, so when I click that, what it has done is inserted a line of code for us, right? Now, for anybody who's sort of likes to avoid coding, really doesn't like it or understand it, look how simple this is. Just one simple line, okay? Just a few letters, and we have a link. And the more that you use this and the more that you use Houdini, you'll start to become familiar with the lines of, like the expressions and the lines of code that it uses on a very, very simple level, and you'll start to be able to type those yourself. And that is how Houdini essentially helps you learn coding, which is actually amazing because it kind of it teaches you, but just allows you to kind of dip your toe in the water, and then slowly but surely, you get used to it, and then you want to do more and more of it. Okay, so this tool that we've used now is essentially a way of creating this line, this expression, and this expression is just it's looking for the value of a channel. So CH means go to this channel at this location and return that value. Now, the location is not a whole path. It could be. So we could start a whole path like /obj/go1, right? But because this is a parameter that is on the same parameter sheet, so it's a parameter on the same node, it doesn't need that path. It just knows exactly where it is. It's kind of like if I said to you, right, you're sitting at your desk right now, oh, could you hand me that pen? You wouldn't ask me, oh, where is that pen? And I have to tell you your entire address so that you know where the pen is. You don't have to start with a full path to where that parameter is. You just use the name, oh, give me the pen. If I said that to you, you'd assume that it's a pen that is close by to you. So that's kind of what's happening here. This is saying, look for the parameter called scale. So because it's given no additional information, it just knows to look on the same node as itself. And remember, if we hover over here, even though this has got the label uniform scale, the name is scale, all lowercase, one word. And so that's what this is doing. So what it means is this value will be the same as this value, always. Okay. Now, a way to see the result of that, because right now we're just looking at the expression, but what if we want to see the result of that expression? Well, if we left click on the word translate, you'll see that it switches backwards and forwards between the result and the actual code. Okay, so that's how we can kind of see what is actually happening. So you'll see these are exactly the same, and as I move, they change together. They always match. But what if I now go to my uniform scale? Maybe let's go to our keyframe over here and change the keyframe. So we go on this one. Maybe I don't want 10, maybe 5 is enough. You'll see that this is already changed to 5 because it was not just a copy. It's kind of like a live link. So it will always share the same value. And so I can now do whatever I want to this parameter and it will be shared over here. I can even break the keyframe and say, well, I no longer want to keyframe this, and I can move it around. I can slide this, and no matter what I do to it, this value will always share the same value as this because they've been linked. Okay. Now there is one other way to do this, which I should show you because it will sometimes come up. So if we copy this parameter again, and when we right click, instead of saying paste relative references, there's another drop-down menu over here, paste other, and these are some, you could say, sort of lesser used paste options because there's so many paste options. They decided to kind of hide away the two that are less often used. Okay, so one thing you can do here at the bottom is paste absolute references. So you see this says paste relative reference. Here it says paste absolute reference. Absolute just means the full path. So this is exactly what I was saying to you. It would be like me giving you the full address of your house and the desk just to tell you to hand me the pen. That's like your house, and then the in the bedroom, like on the desk, and then here at the end is the pen. So it's like literally the entire full like GPS location of that pen instead of just saying the pen, right? So sometimes you do want this. I won't go into why yet right now because that'll be a little bit complicated of a story of when you use absolute and when you use relative. But this is used a lot less often. Okay, so you can see how this still works because it's still the same pen. It's just that we're being a little bit more explicit about its location. But it's actually a little bit unnecessary. We can come in here and take away all of that information and just leave the word scale and it will still work. And it's always linked. Okay, so that's essentially like easy way to start coding. So if it is something that you've maybe avoided in the past, well, now you don't have to because look how easy that is. Now, talking about how easy it is, we're going to have a quick discussion about variables because in Houdini, just like how this one trick of copying and pasting a relative reference create some code, but it is a very user-friendly way of doing so. Variables are so part of Houdini that you cannot get away with it. You cannot use Houdini and not use variables. But again, it's one of those bits of code that are so easy, so simple to use and learn. And once you do learn them, it's actually almost like a gateway into you then learning more code, and so that you can do more things. So variables, if you have never coded before, a variable is just basically a nickname. Okay, so you can have a full name, but nobody necessarily calls you your entire full name. They just have a nickname, or even the word they'll say, "Oh, hey you," or "Hey man," or "What's up, bro," or whatever they choose to call you. Like depends on who it is. You can have a variable, and you can even have multiple variables that reference one thing. Okay, so that's essentially what a variable is. And in Houdini, we have a bunch of variables that are very useful to us. So for example, $F. Okay, so let's type this word $ and then capital F. Okay, so in our uniform scale, I'm going to just type that. So $F, that's all I'm going to type. This is a variable that references the current frame number. So you'll see if I left click, because it's the same as this expression, if you left click, you can then show the result instead of the code. It's 10. Why is it 10? Because my frame number is 10. As I increase my frame number, you'll see that my sphere keeps growing, and because our y value is linked to this expression, it's actually also 176, because this one is saying you should have the value of the frame number, and this one is saying you should have the value of this parameter, and so they both end up with the same value as the frame number. Okay, so there we go. As we drag our scene, it increases. Okay, so you see here we just used $F. $sign is the way of calling any variable in Houdini. Okay, so there are a few different sort of levels or types of variables. There's global, there's local, there's contextual, there's user variables, there's all these different things. We won't go into the difference between them, but if you come across those words, like if you see something that says global variable, well, you know what that is. It's basically a variable, but it's on a global kind of context. So it's not local to one object, it's in your entire scene. Okay, so like $F, okay, is a global variable, right? So that essentially we use $, and in fact you could see here it even pops up a list of available variables that we have in this particular context. Okay, you won't use all of them. You really don't need to go and study a list of every single one of these. There are only some that are very useful, but the ones that are useful are so useful you can't get away without using them. Okay, so you will need to at least learn a few, but I will, throughout this course, will show you more and more of them, and you'll start to become familiar. So $F, for example, is one of those that you're just always going to want to use. Maybe you want something to literally increase over time. Well, now you can do that. You can literally just type $F. Okay, and then another one. So actually, in order to show you this, I'm going to dive inside of this geometry node. So now we're on SOP level. And I'm going to hit tab, and I'm going to type ROP. So we have the thing here called ROP geometry output. Now this is a node that caches geometry for us. So let's say we wanted this sphere to be cached to disk, okay, so that we could read it in a different scene, or so we just basically want to write out this geometry to disk. So here it lets us choose the location, and it lets us choose which frames we want to cache and what format and all that type of stuff. Okay. Well, in the output file, this is the path of where that should be cached to. You'll see that there's a whole bunch of variables that have been used. Okay, and this helps us actually show the perfect example of why these variables are so useful. Let's start with the first one. You'll see that we have the $. So they all start with $, and then the words HIP. Okay, so HIP, all capital. Okay, all of the variables are capitalized, or at least they should be. You can create a custom user variable, and if you do so, you could create it in lowercase, but that's not kind of advised. It's better to stick to the convention that Houdini uses, so you try to stick to all capital letters if you ever create your own variable. But anyway, for now, $HIP. This is essentially the path of where your scene is saved. So if you go file save and you save your scene to disk somewhere, then $HIP is that path to where the scene file is. Okay, so right now, if I middle click on the word output file, okay, I'll explain why the middle click just now, but anyway, for now, if you middle click, you'll see where this is going. So this is showing a location on my desktop, well, in my C drive, which actually at the moment, because I haven't saved my scene, it's pointing to sort of a default location. But if I go and save my scene, then it will point to where that scene is saved. Okay. So you'll see right now, even it's called untitled. Okay. So it's got $HIP, which is the path to here. So that's this section that I've got highlighted is $HIP. So that variable, that nickname, refers to this line. Then we have the word geo. So that's not a variable. That is literally just the word geo. So it's, in other words, because it's got a slash here, it's saying go to where the scene file is saved, but then create another folder called geo. And then inside of that folder, we're going to save the geometry. And the name of the geometry also has variables in it. So it's $hip name, which is a different variable. Hip name is grabbing the name of my scene, but not the path. So at the moment, I haven't saved my scene, so it's called untitled.hip. Okay. So you'll see if I middle click, it'll be called untitled. And then next to that, we have a dot, and then $OS. OS is a variable that is essentially the name of the node. Okay, so whenever you see the words $OS, it represents whatever this node is actually called. So let's go and give this a name. So I'm going to call this whatever. Okay, now when we middle click, you'll see that it's the name of our geometry is going to be untitled, because that's the name of our scene, dot whatever, and then dot 133. But actually that 133 is $F, which means it's saving the frame number. And we need to use $F because when we write out this bgo.sc format, which is a Houdini kind of geometry format, okay, it caches per frame. So it doesn't cache a whole sequence like an Alembic would. So we have to cache a file for frame 133. And we have to cache a whole separate file for frame 134. So in the name of our actual geometry, we need to include the name, well, the number of the frame, because then it's going to, when we click render, if we render this entire sequence, it's going to write out 240 different files, each one of them representing a different frame of this sequence. Okay, so frame, like the file 49 will look like this. It'll have a smaller sphere, and then frame 196 will look like this. Okay, so it will have essentially cached our animated geometry. Now you don't have to go and memorize these, but you can refer back to them. They are on this ROP geometry output, and we will be working with them in the future, okay, quite a lot, especially because we will need to cache out our geometry, and these variables are very useful. But you see how simple they are. You just get to know that $F means frame number. So I want to have my frame number in my name, well then use $F. $OS is the name of the node, like the current node. Hip name, the name of my scene. $hip, the path to my scene. Okay, so we don't have to save it in $hip. We can specify a path, but because this is set by default, this is kind of a cool way of saying, without even having to change that value, if I just clicked cache, I'm now going to cache into the same location where my scene file is saved in a subfolder called geo, and then with the name that relates to my scene name, the name of the node, and includes the frame number. Okay, so just a kind of an interesting use of expressions, and this is something you'll need to get used to in Houdini, is even if you don't want to deep dive into coding, parameters are full of these little kind of tricks and expressions, whether it's a keyframe, whether it's a little short line of code that you've typed, or that you've just, copy and then paste relative reference, or maybe you go and write big long lines of code or snippets or whatever in these variables, in the parameters, or use variables. Whatever you use, there's going to be a lot of ways of essentially setting the value of your parameters to a value that is not standard. So instead of just going, my rotation value is 0, or I can set it to 17. That's fine sometimes, but a lot of the time the power in Houdini is going to come from your ability to link parameters and link this one to the frame number. And so now suddenly, we have a sphere that is expanding over time without having to actually go and set any keyframes. Okay, we can just set it in here, using a variable, set this one to follow it, and then cache that out using variables into a location without really having to do much of anything. Okay. So, I did say to you I would explain why middle click. So there is a little bit of a difference. You'll see here, if I left click on here, we can see the expression. So here's another variable, $f start and f end. These two variables will switch between showing the expression and showing the value. But why does that not work on output file? The reason is because this is a string. So this is text instead of a number. Numbers can have keyframes like this and they switch backwards and forwards. But with text, you need to middle click on the parameter and it switches to this mode where you see it's got like a dotted outline. And that is where it shows what the expression is resulting in. Okay, so it's just a slight difference in Houdini between strings and non-strings is essentially this. You can just left click, and here you have to middle click to show if it's a string. Okay. All right, so this is how we use parameters. Some bits of it are simple, but some can get a little bit more complicated. We will work with them a lot more as we go through this course. But I just wanted to show you how parameters, although they're there for us to essentially set and define how the nodes work, there are also places where we can insert our own kind of code, our own links to this and that, or our own variables and expressions. So this is why it's a fundamental part of Houdini, why it makes Houdini so powerful, is because this is essentially the tricks we're going to use to make things procedural. And once we can make something procedural, that's how we can simulate. So, we can create massively powerful tools that can, maybe you can just draw a line and it turns that line into a road, and then it populates the side of the road with buildings that have various sizes and shapes, and all of the buildings have doors that lead out onto the road. You can build tools like that in Houdini, and it's all fully procedural. But the way to do that is through linking things like this with parameters and sort of linking one to another. So this is why parameters are so powerful. Okay, so I hope that helped, and I'll see you all in the next lesson. Hello, everyone. Okay, so we're now going to be moving on to the third and final aspect of Houdini that sort of adds up to the proceduralism that makes Houdini so powerful, and that is attributes. All right. Now, what is an attribute? So ultimately, an attribute is just another name for the data that is stored on pieces of geometry. All right. Now, when I say that word data, it often kind of scares a few people off. It sounds a bit scary. It sounds sort of like a lot of information or a lot of very technical sort of knowledge that needs to go into working with data. Okay. And although that can be true, it is not necessarily the case, right? On a base level, data or attributes in Houdini are very, very simple and can be used to do a wide variety of very powerful things. And in fact, even very normal things that you're used to doing on a daily basis in other 3D programs would count as attributes or data. But just because it doesn't have that word specifically, then we kind of overlook it. There is obviously a much more complicated aspect to data and what we can do with it. And that means that there's a high ceiling to this. In other words, if you really learn what you're doing and practice a lot, then of course you can do amazing things using this. But what it does not mean that we have to start at that level. And really, on the base level, it is very, very simple to understand, simple to use, and still very powerful. Okay, so let's have a look. So imagine I said to you, right, I gave you all, let's say there's a class of people, so 10 of you in a room, and I say, right, you all have a name. Okay, you know your name, and you also know your age. So let's say those are two attributes that we're looking at, is name and age. And then I also maybe write down a few random numbers on slips of paper and just hand them out. So everyone's holding a number, right? These pieces of information that you have about you are data, right? So it's like you are points on a piece of geometry. So kind of like here on our grid I've got as an example, imagine these points all along here. Each of them is one of you. And so you know your own name, you know your own age, you know what number you're holding on that piece of paper. Okay. And that's all that really needs to happen, is you need to store that information and just carry it with you. So just hold on to the piece of paper, don't lose it, right? And of course, you know your name and you know your age, right? You don't need to know everybody else's, you just need to know yours. And now what I can do is, now that that information is stored, I could make alterations to it if I need to. So I could maybe, for example, say to you, okay, well now everybody just find the person that's sitting nearest to you on your left and give them your piece of paper. So everyone's going to sort of swap it all around, and so now that information is changed and transferred. Okay. And so you can make alterations to it, and that's one of the very powerful things of Houdini, is the fact that because we can alter data ourselves, we can basically customize all of it. But the really most important part of this is that we can read that data. So we can set rules or do sort of perform operations based on that information. So I can say to then the whole class, right, everybody who's got a number that is higher than 5. So let's say the random numbers were 1 to 10. Okay, I say everybody that has a number that's above 5, please leave the room. You know, you go wait outside, and I'm going to be left with a smaller portion of the class. Okay, depending on obviously the numbers that were randomly generated, right? So I have now created a rule and basically deleted a bunch of particles or points on this geometry that we have by setting a rule, setting a limit, and saying 5 is the limit, so anything above 5, leave the room. That is us essentially performing an operation that is based on information on each point. Okay, so that is the most simple way that I can explain the use of attributes or data in Houdini. Okay, so on our geometry we have these different points or primitives, so that like faces or vertices or the whole object itself can all store these pieces of information, and then we can do something with that information. Right. So we're going to use an example here. I'm just going to show you this scene. So I've set up this test scene. I've got a grid here, and I've just done a few random things to it so that it would alter the attributes. And I'm going to show you what that kind of looks like, how we can work with it in Houdini. Okay. So remember I told you when we were working on sort of the window panes and learning how to navigate our scene, we set up the fundamentals desktop. If you haven't done this, you can either go and watch that lesson or just add a geometry spreadsheet to one of your views. So just split this view top and bottom, and on the bottom one, just right click, go under inspectors and geometry spreadsheet. So you do need this available. And this is why I said we always need to be able to see this, because this stores and represents the information or the data on all of our pieces of geometry. Now, I say pieces of geometry because there are different classes of geometry in Houdini, and these different classes can store their own unique pieces of information. Okay. So the 4 main classes that we talk about is points, right? So the actual sort of, in fact, I have to represent my points there. So these blue dots, right? So all of the points that form our geometry. Okay. Then vertices. Okay. So that is, we can actually, we should be able to view our vertices here as well. Now, if you guys aren't familiar with the difference between a point and a vertex, we are going to do that as one lesson. I'm going to sort of show you an example of why these are actually 2 different things. But for now, you can kind of see that there is, for every 1 point, there are 4 vertices within a normal kind of grid here, except obviously on the edge here, we have 1 to 1 or in the corner, and on the edges, we have 2 to 1. But either way, each vertex can store its own sheet of information. Then we also have primitives. Okay, so in this case, our primitives are our actual faces. Okay, so I'm going to just switch into primitive selection mode, and you'll see here I'm selecting faces. So these faces are primitives. But if we had, for example, if we created a sphere that is the entire sphere is just one primitive, it isn't divided up into polygons, then the sphere itself is one primitive. So there are different ways of representing primitives. Also, if you have a volume, volumes are one primitive. We'll get into more detail about that later, but I just want to be clear that primitives are not necessarily only polygons. Okay, they're not synonyms. A polygon is a type of primitive, but there are other types of primitives too. Okay, so we will explore that later on in the course. And then the fourth tab over here is detail. And detail is essentially the whole object itself. So all of the geometry can store a single value for some piece of information. So in that example I said to you before, where all of you are points, so you have a few different pieces of information, your name, your age, and a random number. You're all points, but maybe the entire classroom, the entire group gets a name. We pick a name for the class. Okay, so if I then had to take that class and combine it with the whole, the rest of the school, or like a whole crowd of people, and then I said, all right, everybody from the Houdini Fundamentals class, could you come over here? You would all get up and move, right? Because you all have that shared value of being part of that class. So in other words, that would be a detail attribute, one value for the entire group. But then per point, so every one of you has a unique age, a unique name, and a unique number on a piece of paper. Okay, so that's kind of an example of how this works. Now, what you'll see here in the geometry spreadsheet is this is just literally exactly what it sounds like, a spreadsheet of our geometry broken down into classes. And then the columns are the basically the attributes themselves, right? But broken down, some of them, into components. So for example, with our normals, which is a capital N, okay, for normals, there is an X, a Y, and a Z. Okay, so there are three values that form our one single attribute because it is a vector. But then we have other attributes as well. So we have P, which is the point position. And we have an attribute here called myAttrib, which this one only has one value, whereas you see the normals, N and P, point position, have three values each, X, Y, and Z. All right, so we have 3 point attributes here: position, myAttrib, and normals. And then on the left-hand side, so the rows are the point numbers, okay? So in this spreadsheet, essentially, point number 0 has the following values for these attributes, okay? And we can actually see which one point number 0 is if we switch on our point numbers. So remember, on the right-hand side of our view, there is this little sort of dot with the numbers 1, 2 next to it, and this lets us see our point numbers. Now, if we zoom in over here on the corner, you'll see that this is point number 0, okay? And so point number 0 has the following values. So our X value of this is -5, okay? And this would make sense if we sort of zoom out. You can kind of see the grid over here, and you can see at this kind of height, -25 is over here. So each one of these sort of big blocks that you're seeing is 5. And so from the origin this way, so we're into the sort of -x, this is sitting on that edge, so we're at -5, right? And it's the same with Z, it's on -5 on Z this way. But you'll see I have raised a few of these points up above the origin. So if I scroll down my list, you'll see that some of them, quite a lot of them, have a Y value of 0 because they're sitting on the origin. But then a few of them, if I scroll up, have this shared value of 1.06488, okay? So that's this entire shelf that has been kind of lifted up, all have a different Y value, okay? So that then just kind of shows us these points are different. And so maybe we wanted to, like I said, we removed a whole bunch of people from the room based on a number that they had on the paper. Well, I could do the same thing with a different attribute. So in this case, I'm saying the height. I might say all the points that have a height above 0 must be deleted. And in that case, all of these points would get deleted, but all the points that are touching the grid at the bottom here would not. Okay. So we have standard attributes like point position. P will always exist when there are points. It cannot not exist. Okay, it is one of those attributes that can't even be deleted in Houdini. But there are other attributes that can be totally custom attributes like my attrib. And then we have normals, which is kind of halfway in between. The normals do not have to exist. So if I move to my grid, so if I click on just my base grid, you'll see that I only have P, which is point position. Okay, I have nothing else, right? So if I even middle click on our grid, you'll see that when our information sheet pops up, it says that we have one point attribute, which is P. And then in brackets it says pos. So it's a position, and it is 3 float. What that means is it has 3 values that are floats. So in other words, they're not integers. They can have decimals. So 3.88, whatever. That can exist. So that's all that means. So it gives us a bunch of information about what is on this geometry. Now the very next node that I'm doing over here is I am setting color. Okay. So if I middle click here, you'll see now we have 2 attributes. We have one point attribute, which is still P, but I have one primitive attribute, which is CD. Now CD is another one of those attributes in Houdini that are default, but they do not have to exist. So our grid was happy to exist without color. It's Houdini kind of knows that if something doesn't have a color attribute, it will be just this kind of gray white. Okay, so that's the default color that it displays in the viewport. But if we create color, it must be called CD, because then Houdini knows how to represent it in the viewport. So now we're able to make some green and some white, gray primitives because we create CD. If I created a primitive attribute called color, or coal, or just whatever we want to, I can store values in that attribute, but then it will not display in the viewport. Only when an attribute has the name capital C lowercase d will Houdini be able to represent that in your viewport as a color. So it's kind of one of those sort of reserved keywords in Houdini where it says if you create an attribute called CD, then I will treat that as though it's color. Okay, same with normals. Your normals are called N, so capital N. You can store any numbers you want in that, but if you do, it is always going to be a vector, and it is always going to represent them as essentially the normals on the surface. Okay, so you can see here these arrows are the normals of our points. Okay, so on the slope here, they face a slightly different angle, but everywhere else they're facing straight upwards. Okay, and so that's here. I'm using this facet node, can create normals. Okay, don't worry too much about what nodes I'm using here. We will get into this more in future, but ultimately I'm just using a color node to set color. I'm using a transform to move the points upwards. I'm using a facet to create normals. And I'm also using a snippet of code over here to create a custom value for my attrib. Okay, we will learn how to do all of this separately. Okay. Now, one thing I want to point out is you see here, if we sort of middle click at the end, so now we have all those attributes that have been created. You'll see we have 3 different point attributes and 1 primitive attribute. So when I created color, I chose, if I show my parameter sheet for the color node, so with color selected, and I hit P on my keyboard to show the parameters, you can see here, so it's applying only to a specific group of primitives. Okay, so this, I will show you how to create this, where, because I didn't go and manually enter these numbers, we can just create a selection and then it turns that selection into this. Okay, so we'll do that in future, but I just want to show you what an attribute is. But you see here, I've set the type to be primitive. If I change this type to be points, then it's going, sorry, not the group type. So this here is actually what these represent, okay? But over here, the class, this is the one I need to change. So if I change that to points, you'll see what actually happens is these, the color kind of blurs on the edge here. And that's because this point is green, but this point is gray, so halfway in between, it kind of interpolates, right? And now you'll see if I middle click, we've got 2 point attributes. One is CD and one is P. So CD, color, can be a point attribute, or it can be a primitive attribute. And depending on which one I make it, it will represent itself differently in a viewport. So here I have 4 point attributes because my normals, my attribute, so my custom attribute called my attrib, my color, and my point position are all point attributes. If I change color to be a primitive attribute, we get a solid line because instead of coloring the individual points, it's actually coloring the faces themselves. And so there's no need to kind of blend from green to gray because this entire face is green, this entire face is gray, so there's no need for a transition in between. Okay, so I just want you to sort of see through this that there is a difference between points and primitives, and we can do the same with vertices. We could create separate vertex attributes, and we can create a detail attribute, which is essentially attributes for the entire object. Now, the color that we're creating here, the position that is being done by the transformation, and the facet node which calculates normals, these are all attributes that Houdini expects to find. Like I said, CD is a well-known, it's a reserved attribute name. Position is a reserved attribute name, and normals is a reserved attribute name. But we can create custom attributes in Houdini, and this is one of the incredibly powerful things that we can do. It's so easy to do, and then the benefits of it are massive. So this is the equivalent of me creating that random number on a sheet of paper for you, okay? You already know what your age is and you expect to have an age. Every person has an age. So it's not something that was foreign to you that I had to kind of explain. I just said to you, well, remember your age. That's one attribute that I want you to have. That's the same as creating color on these points or these primitives. It's, you know, it's an attribute that Houdini already understands and expects you to be able to create. Okay, so it knows already what to do with it. But when we create a custom attribute, that's like when I wrote a number on a piece of paper. That number could have been anything. I decided that it was a random number between 1 and 10. It could have been between 1 and 1,000,000, or it could have been a random word, or a picture, or a color. Like I could have just, you know, given you different slips of color paper, and, you know, so then I say, everybody that has red paper, please leave the room. So depending on what I decided that attribute would have, I can decide also the rule that goes along with that. Okay, so, you know, don't worry about the code here and how we're creating this attribute. We're going to talk in future about how to create them. There's a lot of different ways you can create them, alter them, and use them. But really what I've done is I've defined that the my attribute is an attribute that will hold a value that is either 0 or 1. Some of these points will have a value that is 0. Some of these points will have a value that is 1. Okay, so if I go down my geometry spreadsheet here, you'll see that some of these are all 0. But as I scroll down, you'll see that some of them have a value of 1, right? Essentially the ones that are listed in this list over here. So for example, here we'll see that these all, so from 50 to 53, all have a value of 1. Well, in this list of points here, it says that 50 to 53 have a value of 1. Okay. Now, like I say, I didn't generate this list on my own. I created a selection. I dragged a selection, and I can populate this automatically. But something cool you can do in Houdini is, because we can create attributes and then base things on it, I could have said, oh, well, everything that is green and is above a y value of a certain amount. So in other words, all of these primitives over here that are sort of raised up above the grid and are green, these ones would all get a my attrib value of 1. And if that was the case, now I'm able to essentially set some rules saying, based on 2 pieces of information, I then create a third. And that is essentially what proceduralism is. Okay, we are using something to determine another. And so then if that first thing changes, so does the second, right? That is really powerful and what Houdini does so well. Okay, so as you can see here, we are able to see color in our viewport. We're also able to see the height of these points in our viewport. We can't see our normals until I switch them on, but on the right hand side on this tab, one of them, so you'll see here the circle with a line coming out the top right of it. If we hover over that, okay, it's not displaying on my side, but it should on your side probably say display point normals. And so we're able to see these as well. Okay, so we are able to represent and visualize the values of our attributes in our viewport in different ways, whether it's color or with these sort of markers that show you direction. But what about the my attribute? Okay, the my attrib. This is a custom attribute that I have created, and we can't see it in our viewport. If I can see it in our list, but that is very difficult to see. How do I look at this and just instantly know which of my points have this my attrib value? Okay, so there are ways of doing this, and a really cool way to do this is if we click on the eye, so to pop up the sort of pop up information sheet. If we middle click, it goes away as we sort of hover or let go of the middle click. So it's a convenient, quick way to see this information. But if we want to do anything to that information, we have to click the eye so that it pops up. And one thing that we can do with this now is actually you can click on an attribute that you have. So I can actually click on my attrib. And when I do that, it creates a custom sort of visualizer that helps us see what that attribute actually is doing, right? It overwrites the color that we have in the viewport, but it's only in the viewport. You'll see here, if we look at color, which is actually under our primitives, because remember, we created a primitive color attribute. So if I go to my primitive attribute tab, you can see our color is set over here, okay? And color was either, some of them are 111, which produces white, okay, and 010, which produces green. So you can see the values here. Now those haven't changed, even though what we're looking at now is blue, white, and red, because this is just a way of visualizing it in your viewport. It has not actually changed your color. And if we switch that and my attrib back off by clicking on it again, you'll see we still have our color set correctly. Okay, so this is just a way of temporarily visualizing that attribute. And so wherever it is red is a value of 1, wherever it is blue, it is a value of 0, and then white is the transition between those two. So it's kind of fading from red to blue, okay? And so all of these points on this side are the ones that I grabbed a selection. So I kind of went like this. I grabbed a whole selection of points and then went and set my attribute based on the selection. Okay, so as I've said many times before, don't worry if you're confused about all of this. You should really kind of just be listening and following along at this point. I will show you how to do all of these things later on, but the really important thing right now is to understand what an attribute is and sort of how it's represented in Houdini. So we just have this, I can give it a name. I mean, I could call it whatever. I've now called it my attrib, but I could call this whatever I want, and it will now be called whatever I want, right? And it still has the same kind of values. And you'll see I can, if I scroll up to the top, you can actually sort by the value of an attribute. So if I click on the word whatever I want, it sorts by the value. So I can see I have a whole bunch of ones and a whole bunch of zeros, and now it's sorted by that attribute. On the left hand side, you'll see that my point numbers are now not in order. Okay, so these are kind of random, but because it's sorted by whatever I want. And then if I click on this top left hand thing, then it's going to sort by color. So right now it's sorting ascending, and now it's sorting descending in terms of point number. But I could sort by something else, like the Y value. So here's all of my zeros, and here's all my 1.06s. Okay. So this is just a little bit sort of about attributes and what they are in Houdini. We can have custom ones that we can call whatever we want, and we can give them whatever values we want. We can create them using other nodes. Some nodes are specifically designed to create them, like the color node is meant to create color for us, and it is designed to help us with that. It says, okay, what level do you want it created on? And you've got a nice convenient color wheel here that we can select from. So we could change it to purple instead of green. We can do whatever we want. And this whole node is designed as a way to help us setting the color attribute. Okay. We don't even have to tell it that it needs to call the attribute CD, because it already knows that and it's already designed to do that. But if we wanted to, we could create our own custom attribute called CD, and we could overwrite that. Okay, so we can create, I'm just going to create a primitive wrangle here. Don't worry about what I'm doing here. This we'll learn how to do later on. But I can go and set this value to be 0, 0, and 1, right? And so now all of our primitives will become blue because it's red, green, and blue. And I've specifically set it to be like that. I could go and make that 0.5, and now we have kind of like a light turquoise blue. Okay, so we're able to custom override these attributes with whatever we want, bits of code or just static values. We can set them using pre-built nodes, create custom attributes, base things on those custom attributes. Maybe we wanted to delete based on the color value here, for example, then we could do exactly that, right? So there's lots of cool things we can do with this, but really at the end of the day, what it comes down to is that there are pieces of information on every point, primitive, vertex, and every object. And these values can be whatever we want them to be, and we can do things based on that information as well, which is really where it becomes very powerful, because you'll see in future what we're going to do is create an attribute and then do something based on that attribute, and then do something based on the result of doing something based on that attribute, and it forms this long chain of kind of cause and effect. And then all we need to do is change the beginning, and everything down the chain readjusts itself. And that is super powerful if we do it in the right way. It can also be scary and destructive if we don't do it the right way. For example, here, if I go and change just even the resolution of my grid, so I add a few more rows and columns, then weird things start to happen. Okay, like here you can see my my selection has not really stayed, just that one side. And the reason for that is because I'm using numbers. So I've moved or I've set the color, for example, based on primitive numbers. These numbers remain static. So if I change something upstream of this node, then it's altering what's going in. But this node is still trying to set primitive 4 to 8 to be purple. So wherever primitive 4 to 8, so 4, 5, 6, 7, 8 are, it's going to make them purple. But if we adjust what's coming in, then primitive 4, 5, 6, 7, 8 are all in different positions, right? So, if I display my primitive numbers, you'll see there's 4, 5, 6, 7, 8. But as I adjust the resolution of my grid, those primitive numbers end up in different positions. So this can be a desired effect, maybe, or maybe not. And so what we're going to learn about proceduralism is that it can be powerful, but you also have to be very careful with it. And as you get better with Houdini, you learn how to navigate that balance. And when you can, then you can build systems that are fully procedural, which are really powerful. Like I said in the last lesson, an example would be to build an entire city automatically. You can literally build one tool that just makes a city. And then you just add a road and suddenly it readjusts everything. Creates that road, creates a sidewalk, creates some trees next to it, changes the buildings, everything based on where that road is. But you can do that if you use data, or in other words, attributes. Okay, and so that is essentially what an attribute is. Now, I hope that this has made sense. These are just some various examples that have helped try and sort of explain what data is. But if you still don't understand, don't worry or panic, because you will understand as we start to use it. An explanation sometimes helps, but also sometimes physically seeing it and putting it into practice is going to help. And when you combine those two, it'll eventually all start to make sense. Right. So hope that's helped, and I'll see you in the next lesson. Hello, everyone. So now that we've covered nodes and parameters and attributes, we can move on to one of Houdini's most powerful features, and that is proceduralism. First, what does it actually mean? What does proceduralism mean? What does it mean for a system to be procedural? Well, in order to illustrate this, I've put together a bit of an example to show visually what the difference between sort of a non-procedural system and a procedural system would be. Okay, so let's have a look here. So I have a man and I've got a dog. Okay, and we are going to give these two creatures some information, right? We're going to give them some instructions and we're going to see how they handle that. Okay, so the first instruction that we give is to say hello and shake hands, right? So if we had to give these two different beings this instruction, how would they handle that? Well, the man, of course, would do exactly what we tell them to, right? He'd be able to say hello and he'd be able to shake hands. But the dog would be confused, right? Because this information doesn't actually make sense. It's explicit information. In other words, it is saying do exactly these steps, and these steps do not take into account the different being, okay? A man can shake hands because he actually has hands. The dog doesn't even have hands. So even if you can kind of, extend a paw, that's still not really shaking hands, okay? He doesn't have hands. He also cannot speak, A dog would be able to bark or howl or something like that, but he literally cannot form the words hello. So this set of instructions means nothing to the dog, but to the man, he can follow them, step by step. Now, instead, if we gave a more implicit set of instructions, okay? So in other words, it takes into account the information that's already there, okay? So instead, we change that set of instructions to greet whoever is at the door, okay? Now, the man would still go ahead and do exactly what he did before. He'd say hello and he'd shake hands, right? Because that is how he would greet whoever is at the door. But because this does not give explicit instructions about exactly how to do that, it kind of relies on the man knowing or understanding what it is to greet. And so when this is applied to the dog, we get a more positive outcome. Okay, the dog is able to greet whoever is at the door. He just does it in his own way, right? So he'll sniff and lick the hand or do whatever, So it depends how well trained your dog is, but basically he's able to still carry out the instructions because the instructions allowed for a little bit of room for interpretation, really. The dog and the man did two different things, but the instructions were successfully followed because the instructions were sort of vague enough that they allowed for the difference in the two initial pieces of geometry, really, because that's what we're talking about here. Is when we talk about instructions, what we're really talking about is the nodes that we have been talking about. So we create a transform node, or something that's going to scale our points, or set something on fire, or do whatever. Now if we tell it exactly which pieces of geometry to do it on, and how that should work explicitly, then it will work on some pieces of geometry and not on others. Okay, so let's look at another example here. So same kind of deal. We give a different set of instructions. So we say, fetch your leash and wag your tail. Right? Now the man is going to be a little bit confused. He may or may not own a leash for himself, but he certainly can't wag his tail, okay? Because he physically does not have that piece of geometry, right? That limb does not exist on him, and so he cannot perform that action. And this is kind of similar to what we're going to find in Houdini, where sometimes if you are meant to take a certain piece of geometry and maybe emit particles from it, but what if that geometry doesn't exist? Like if we feed in a different source, a different piece of geometry in the beginning of our system that doesn't have a tail, then how can it possibly wag that? And so this needs to be turned into something a little bit more implicit instead of being explicit. Because when it's explicit, it's going to sometimes break, like on the left here with the man, whereas the dog will be able to successfully perform that action. And if we change our instructions to account for what is fed in at the top, then it'll be more successful. So in this case, we're saying express your desire to go for a walk. Okay, so the dog would still fetch the leash and wag his tail, so everyone knows that means let's go for a walk. I'd really be happy if we did. But the man would simply say, I'd like to go for a walk. Okay, because the man is able to speak, but he does not have a tail to wag, and he does not need a leash to go out for a walk. So they are both performing the same action in two different ways, and both are successful. Okay, now that's obviously a little bit of a silly example, but this is the idea behind what it is to be procedural. And the thinking behind that, the way that we had to carefully reword the instructions, is that kind of thinking that you're going to need to use in order for Houdini to be as powerful as it can for you. Look, you can give it explicit instructions. You absolutely can. And sometimes that is going to be the fastest approach, because maybe you don't need a procedural system. But the true power of Houdini comes in applying that proceduralism, just altering the way that we sort of set up our nodes, or the way that we feed the values into our parameters, so that things are implicit or procedural. Because then when geometry changes, our system still works. This happens a lot because in a studio you have a model, so you get given a character. And so we go, all right, we're going to take this character and maybe do some kind of cool effect. Maybe he's got glowing red eyes. Okay, so we go and select those polygons and make the eyes glow and emit some kind of magic out of it and little particles. And okay, we've got a really cool looking effect. And now modeling says, okay, we've made some changes. And they go and give you a new piece of geometry. Looks very similar, but they've had to add some edge loops here and there, subdivide, maybe add maybe the guy's got a hat now or something like that. And so there's extra geometry in that, in that model. When you click play on your simulation, your glowing red eye simulation, suddenly his left hand is glowing red and his eyes are not. And this is because all of the point numbers and primitive numbers have changed. The total count has changed, as well as the actual individual numbers have changed. And because we would set up a system that relies on those numbers, which is an explicit thing to do, it has now broken and giving us results that we're not happy with. Instead, if we used some implicit information to figure out which polygons belong to the eyes, then even when they give us a new piece of geometry with different points, it still works. And that is the reason why this is so powerful and why we're going to use it all the time. Okay, so I'm going to show you a quick practical example of how this kind of comes into being in Houdini. And then we're going to kind of discuss some pros and cons, and then I'll show you another final example. So we're going to try and show you sort of take this from being theoretical to practical. So I'm going to drop down a geometry node, okay, so geo node, and go inside. Now, let's drop down a sphere, SOP, okay, so we're on SOP level, and we're going to drop down a sphere, right? Now, when we do this sphere, if we pop up our parameter sheet, this type is primitive. And what a primitive kind of means is that it's actually one, the whole object is actually one thing, so it's just a sphere. It's, it's almost like it's pre-packaged into this whole like sphere. It is not individual polygons that form a sphere, but is just simply one big sphere. And that's not what we want, because we want to actually cut this piece of geometry up. So I'm going to change this to you can either go polygon if you want, or polygon mesh I prefer. You see here, if I click on this third button from the left on the, third from the right on the view, and go to show wireframe shaded, we'll see here we can see our geometry. Now, polygon mesh is going to give us quads exactly like this, kind of arranged in sort of rows and columns. Polygon is going to give us triangles. Now here we can increase the resolution by changing the frequency of this, or we could go to polygon mesh, and then we can alter the rows and columns to get the more resolution. Okay, so let's go to polygon mesh, and then just set your resolution a bit higher. It doesn't have to match exactly, but just something. Okay, so we've got a sphere. Now let's cut the whole bottom half of the sphere off. Right, now one really easy way to do that is with a clip node. So hit tab, type the word clip, and drop it down. Okay, so it's got an error, but that's just because it requires some data. So let's feed that node in. So we're going to left click, and then we'll move our display and render flag to this. So now we can see what it's doing is it's cutting it in half at the origin. All right. You can play around with the settings of this clip if you want to, and I would suggest and encourage that you guys experiment and play. Every time we drop some nodes down after the lesson, play around with the nodes, see what they can do. That's the best way to learn. So here we can essentially choose an axis to essentially clip on. So at the moment we're clipping on the y-axis because this has a value of 1 in y, but then 0 in x and z. So in other words, along the y-axis, it's cutting it in half at 0. Okay. If we change this distance, it will decide where that line is that it's going to cut. And we can also choose whether to keep the primitives on the top or below that clip line, or we could even keep all of them, and then you'll see what it's doing is it's adding an edge loop. It's cutting it, but it's keeping both halves, right? But anyway, we're going to just revert this all to defaults, and we go back to clipping. So we're going to keep the primitives above the plane and clip to 0. So we're just cutting it in half, essentially. All right. And now what we're going to do is drop down a color node. Okay, so we're going to plug this in, and let's go and set this to whatever color you want. So just pick a color. I'm going to go orange, and that's going to set the color for our points. Okay. And make sure it is point level, because you can apply it on primitive level, but in this case we're going to do points. And then in the group section over here, I'm going to ask you to type the @ sign, so @ then capital P dot X greater than, so the sort of right arrow greater than symbol, equals 0. Okay, and then we'll hit enter. But then under group type, let's change this to points. Okay, so what we've done here, and in future you will start to understand these little lines of code a little bit. The more and more we sort of use them and apply them, right? So I'm going to keep using things, and you're going to pick up little tricks. But anyway, what we're essentially saying here is take the point position x value. So remember here in our parameter sheet, we have our point position and we have x, y, and z. Well, I'm essentially saying at p dot x is essentially referring to this number in this column. Okay, so it says take that number in the column, and if it is greater than or equal to 0, then those are the only points that are going to get turned into orange, but the other points will not. Okay, so these over here have a x value that is less than 0, and so they do not get colored orange. All right, so this is just a simple expression checking for point number. Now the @ sign is because it's grabbing a value from an attribute. Okay, so you use @ for attribute, and then it's the attribute name, which is p, but because we're wanting only the x, so not the whole of p, but specifically the x component, we say .x. Okay, so that's what that is for. If we took it away, it would just be the whole vector, okay, which does actually work in this case, but it's better practice to do it correctly. So we say at p dot x greater than equals 0. Okay, so this here we have an expression. Like I said, through parameters we can use code and expressions to be procedural, and we can use this clip node, which the whole way that this node works is procedural. It was not deleting those bottom primitives or points based on a selection. It is just deleting anything that is below this line, okay, at the origin. So because we've set this up in this way, this is an implicit or procedural system. And so the real benefit of this is we can drop down a different piece of geometry. So let's drop down a box. I'm going to move my display and render flag to this box so we can see it for a second. And you'll see that this only has 8 points. So if we middle click on this, you'll see it has 8 points, 6 primitives. Okay, this is not enough resolution for our system. Okay, so I'm like what we did at our sphere. I just want to increase the resolution here. Instead of going polygon, I'm going to change it to polygon mesh. And then you see here the divisions will determine how much resolution there is. I'm just going to hover over axis divisions, middle click, and then drag to the right so that we are basically going to subdivide this on all axes a little bit more. Okay, so now that we've got a higher resolution box, all we need to do is plug this box in, and then we'll move our display and render flag to the end. Now look at this. Our system, in other words these two nodes, is designed to cut the geometry in half. Everything below the origin must be deleted, and everything on the right of the x axis will get turned orange, and then everything else is white. We can change this wire to be plugged into our sphere, and then we get this result. Change it to our box, and we get that result. In fact, we can even drop down a torus and plug that in, and you see there we get that result. So you see how this, because it is implicit, it is readjusting itself the whole time. Now this right here is why Houdini is so powerful. The fact that these systems are live, that the nodes are doing what they do, but kind of constantly, right? We haven't taken a torus and then deleted the bottom half. And so now we can't get that bottom half back. And if we want to say, oh no, well actually I don't want to do it with the torus, I want to do it with a box, well we now have to take our box and then very explicitly go and select the bottom half again and delete the bottom half, and then select the right hand half and then change the color. We don't have to redo any work manually, because this flow of data from one node to another is procedural. It's fully live and readjusts itself depending on what we plug in. Okay, Now that works in some cases, but we need to be careful and make sure we do things the right way so that it works. Okay. If we went and changed this color node to not have an expression but actually be pointing to a specific set of points, then that would not work. Okay. So we can test it, like we can select our color node, and on the right hand side here, if we click this arrow, it's going to pop up a selection mode for us, and we can select some points and then hit enter on our keyboard. Okay. And then you'll see it's still displaying our points. That's just because we're in point selection mode. You can right click on here and go to primitives, or hit 4 on your keyboard to just go back to this, because it's easier to see that. We don't have to see the points. So you'll see here, this is fine. We have half of our sphere is orange and half of it is white, but then we change to the box and look at what happens. See, that is not implicit, it's explicit. We've got a specific set of points that have been turned orange, and now that we adjust the point numbers or the point orders, that is kind of all messed up. We can plug our Torus in as well, and you'll see that that doesn't quite work. Or even with our box in, if we readjust the resolution of our box, you'll see that things don't quite work out. Even on our sphere, which is the one where it is working, if we change the resolution, it's then going to start breaking, right? So as we change our resolution, depending on how we do it, we then get results that we wouldn't quite want. Okay, so I hope this one helps. I'm going to show you a different system that is going to also help explain this, so we can really fully understand proceduralism. Okay, so we're going to create another geometry node and dive inside. Okay, now let's drop down a box. And what we're going to do essentially with this box is we're going to be creating a wall, right? And then we're going to carve a window out of this wall, but we're going to do it procedurally so that we can readjust it very easily. Okay, so I'm going to select this box, and then we want our wall to be sitting kind of on the ground, right? If I increase the height of this wall, so if I change the Y size, so the middle one of Y, right, and increase this value, half of it's dipping down under the ground, okay? And that's just because the box by default starts centered around the center of the world, right? Centered at the origin. So what we want to do is use just a little trick to set this to start from the ground and go upwards only, okay? And this trick, remember we have done this before, where we right click on the this parameter, so 5, okay, on this one, we right click and say copy parameter. And then on our center on Y, okay, so this value here is going to determine the height of our box, right? Well, what we want to do is right click in there and say paste relative references. Okay, so remember that creates this line of code that references this number. So this is 5, this will be 5. Okay, so as we increase that, so will the height increase. But the thing is, we want it to, you see here, it's actually too high, right? A box that is, let's say, 2 meters high would need to be one meter above the origin if it started at the origin, right? Because there's 1 meter that would be below and 1 above. So it needs to be moved up by half of the height. So in order to halve this, if we click on center again so that we can see the expression, okay, we're simply going to add to this expression. And the cool thing with expressions in Houdini is you can do simple maths. So the star key on your keyboard is multiply. And so you can say multiply by 0.5, which is half, okay? So when we have this parameter value, but multiplied by 0.5, that's going to result in 3.25. But this multiplication here is implicit, okay? It's fully procedural. So as we adjust this value, this is constantly taking this value and halving it. And so no matter what we do, our wall will now sit on the floor, okay? So let's make this 10 high, right? So we'll just enter 10 there manually. And then let's also make it wider. So let's make it a nice sort of wide wall. And maybe this is a little thick, so maybe we'll change our Z to 0.5. Okay, something like that. So there's a nice wall, right? Now, I'm not going to change it to polygon mesh and give it more resolution yet. We are going to do that in a little bit, but let's just leave it as a default box for now. So we've got our wall, okay? One thing, by the way, in Houdini, don't forget that you can rename your nodes. And so if you do want to get used to what each node is doing, sometimes it's good to keep track. So instead of calling that box, let's call it wall, so that we can kind of visually understand what this is actually doing. This is creating our wall. Right. Now what we're going to do is we want to cut a hole in this. And the way to cut a hole is with a function called Boolean, right? So you'll see here there's a function, well, a node called Boolean, but there are a few other ones. There's Boolean intersect, Boolean shatter, Boolean subtract. The kind of the cool thing or the trick here is that these are all the same node. But Houdini does this sometimes where they know that people use the nodes a little bit differently. So they include several kind of variations in the tab menu. And so if we drop down a Boolean subtract, it's actually dropping down a Boolean, but it has certain parameters automatically set for us so that it's set up to be in subtract mode. So it's up to you whether you drop down just the actual Boolean on its own and go and change it to be subtract, right? Or we can just drop down Boolean subtract, okay? Either way, it really is the same node. Now, what this node wants from us is one piece of geometry that it has to absolutely have one piece of geometry. But then the second one is optional, but it's there for us to decide essentially what we want to cut this wall with. And so we're going to be subtracting a shape out of it, okay? So let's drop down another box. And this is going to be our window. So let's call it window, okay? I mean, really, technically, this isn't actually our window. This is the window shape, like the window cutter, really, like the cookie cutter for the window, but you know, it kind of amounts to the same thing. And we're going to plug this into the second input of our Boolean, right? Now, in Houdini, most nodes, in fact, all nodes really, the first input is the most important or the most special. Generally, anything that's coming in on input 1 is going to be the thing that comes out, really, okay? The second, third, fourth, because sometimes there are nodes, like for example on our wrangles, you see this has 4 inputs. So sometimes you'll have multiple inputs, but it's always the first one is the one that's kind of the work is being done to this, but the other inputs are essentially extra references or tools or something that it's saying, okay, well, I need to cut this using another shape. But our box, you'll see, if I select our box here, you can see it because I've got it selected in my viewport. So it shows it as a wireframe. But when I click away, that disappears. This box does not continue existing. It only is used as a way to cut our wall. But what moves forward out of here is our actual wall itself. Okay. So at the moment, it looks like we've got a little a mouse hole in the wall down there, but let's change this and increase the size. Okay. So we can do this on our box node itself if we want. So we can click on our window box and we can change the size. So you could middle click on size and change it here. And you can change the center, and so we can move it up. Or if you want, what you can do is drop down a transform node. Now, transform node essentially does what we just did, but it can kind of do it to any piece of geometry. So you can translate, rotate, scale. There's all sorts that we can do with this. In fact, even in here, oh wait, they do have rotation, but I think before they didn't. In like older versions of Houdini, there was no rotate. So you'll find that some pieces of geometry don't have all the options in the SOP that creates them. You generally often want to actually create it as at default and then add a transform node and use the transforms to set its position and scale. So we can come here and set a uniform scale. Okay, so in this case, it's going to result in the same, but I just wanted to point out that most of the time you're probably going to want to rely on using the transform node, because not every node will allow you to reposition itself, scale it, rotate. Okay. Right. So there we have a window cut out in this hole, in this wall. And it's added, you'll see here, it's actually added an edge loop, but that's just because of the way Houdini wants to kind of work with this. It's struggling with this n-gon if it doesn't actually run an edge all the way from that corner to there. Okay, so it's taking some liberties here and doing certain things that it sort of needs to do. Obviously, if we go and switch back to smooth shaded without the wireframe, you won't even see that. But it is just adding an edge loop there, so I just want to point that out. Okay. So now that we have this, what we want to do is actually create a bit of a window sill. So cutting a hole is not really just everything that we wanted to do. Let's actually create a window sill. So we want to go and select these edges over here, right? Our inside edges, because we're going to turn that into our frame and a windowsill. So we make sure we're in selection mode. So on the far left hand side, let's click our cursor. So we're in selection mode, and then you can hit 4 on your keyboard. We're hovering over the viewport, or right click on the top here and go down to primitives, because we're wanting to select our faces. Okay. Now we can go and select that face, and then you can shift click to add to your selection. And remember to move around, even though we've got our selection, our selection tool is activated, you can hold spacebar, and so we temporarily activate our view tool, and so we're able to rotate so we can see underneath. When you let go of spacebar, we're still in our selection mode, so you can hold shift and select. And so now we have these 4 edges selected. Okay, so that's one way to do it. Another way to do it as well, so I'm going to just drag select here to get rid of all the selection. We can click on one polygon, and then if you hold A on the keyboard, it lets you select essentially an edge loop. So if we hold A and hover over one polygon, it's going to essentially try and select up until that polygon. So you see, if I go across to the opposite side while holding A on my keyboard, you can actually see that the top edge over here is being selected as well. See, if I hover over just one, it only would select this left-hand polygon, but if I hold A and just sort of move my cursor, you'll see it wants to select the top and the bottom. And that's kind of okay. It would help us, it would save some time, because we could just click there and then it would select the top and bottom, top and left, but we'd still have to select the bottom. But another way we can do it is select the full edge loop. So if we hold A, but then we middle click instead of left clicking, what it will do is continue that loop and select the whole sort of loop. So now in this case, we've selected a polygon loop. So we click on the right hand side, hold A, middle click on another primitive, and it doesn't really matter which one, it will select the whole loop. Okay, so that's another way to do it as well. Now, with our cursor over the viewport, and with our 4 primitives selected, okay, make sure your cursor is over the viewport here. We are going to hit delete on our keyboard. Okay, now what happens when we hit delete with something selected and our cursor is over the viewport is it automatically creates a node for us. So this is kind of a shortcut or a tool that does what we could manually do. We could drop down a delete node, right? Now, there are a couple of different types of deleting in Houdini. There is a node called delete, and this is a very powerful node for deleting. It lets us delete with bounding boxes and using other reference geometry or by a pattern. So you can do lots of things with it, but it is kind of heavy, especially if you have a huge piece of geometry. Like, let's say we import an environment that is millions of polygons in size, then the delete can sometimes be a little bit too heavy. It's powerful, but I would only rely on it if you absolutely need to. But a simple case of deleting polygons, blast is the node that we're looking for. Okay, it has far less settings, far fewer things, but it is much quicker to calculate. So even on heavy geometry, you'll be able to delete polygons or points very easily. Now, we could just drop down a blast node. That is possible. And you can plug it in, and we could go to this blast node, and you'll see on the blast, because there's nothing selected, it deletes everything. But we can get around that by just clicking this arrow on the far right hand side of the group. It'll go back to, it kind of goes to this weird mode in here where it sets our render flag on the node and display over here, but don't worry about that. Just in your viewport, once you've clicked that, is go ahead, select your primitives. So this time I'm also just going to hold A and middle click, so it selects the full edge loop. And then with my cursor over the viewport, I hit enter, and so it's going to commit that selection to the group over here. Another way I could do it if you really wanted, and sometimes it is relevant, is we can actually just manually go and add the primitive numbers. So if I show my primitive numbers on the right hand side here, I can click this button and it shows the primitive numbers, and this is 6, and that's 9, and that's 7, and that's 8. Okay, and so we could, in our blast node, you can either list those, so you can say 6 space 7 space 8 space 9, and it will still work. You'll see here we now have a gap in our wall instead of having those inside edges. So we can list them. But if they are sequential like this, you can actually list them in a range. So just put a dash, so between 6 and 9, and it will still delete them. Okay. And if you wanted to delete something else, so we could say 6, 2, 8, and then space 9, and it will still delete them all, because you can have a range and then a space and then another number or even another range. Okay. So you can manually enter this information if you want, but that is a lot more work than I'm willing to do for this. Why do that much work if you can just select it? Okay, so there's a lot of ways that we can select it, and you'll see here the group type is set to primitives, and this is because we were in primitive selection mode. If we had gone to points, then we would essentially it would be set to point mode. If we change it to point mode now, it's going to look a bit weird because it's not deleting primitive 6 to 9, it's deleting points 6 to 9, and the point numbers don't relate to the primitive numbers, so you end up with something looking really weird. Okay, so I just want to be very clear about what's really happening here. Okay, so this is the one that we manually created, but I'm going to delete that because the one that we did using just the hitting delete on our keyboard is set up exactly the same. You see how it's set up the selection 6 to 9, and it switched to primitive mode. So it did everything that we wanted it to do. Okay. Now, what I actually want is to do the opposite of what we just did. I don't want to delete these inside edges over here on my window. I want to delete everything other than those inside edges. So I want to isolate those. Well, what we can do here is just click delete non-selected. If we tick that on, it will then invert the selection. So we don't have to go and actually invert these numbers. We can just say, yes, I want you to look at primitives 6 to 9, but then here we tell it what to do. So we say, I want you to delete the non-selected primitives, not the selected ones. So here we can switch backwards and forwards between which ones are deleted and which ones are not. Okay. So what we're going to do is we're going to take these faces and we're going to extrude them. We're essentially wanting to create some thickness here because these are just one polygon thick. By the way, I'm just hitting, I'm holding spacebar because I want to activate my view tool, and I hit F on my keyboard so that it frames my selection at the center. Okay, because while I was rotating, I noticed that it was doing kind of weird things and it was hard to keep it in the center. So if I just say hold space and hit F, it now centers this, so it's a lot easier. Okay, so we have these thin edges and I want to create some thickness. So we're going to extrude them. So in our network view, I'm going to hit tab, I'm going to type poly extrude. So there's a lot of nodes here that actually relates to, polygonal modeling, and we are going to go through a lot more of them next week. Actually, we're going to be talking a lot more about geometry. So this is just an intro, but there are under the polygon tab, and in fact even under some of the other tabs as well, like under manipulate, you'll find that there are nodes that relate to polygon modeling, and so they are all prefaced with the prefix poly. Okay, so there used to be an extrude node, and in fact you'll see here it still is there, but it's kind of been archived, so it's called extrude old. Rather, don't use that, just use poly extrude. This is the new version of extruding. Okay, so but if you type just extrude, you'll see that poly extrude does appear, because Houdini is set up in such a way that it does look for the words inside. So even if you type extrude, you'll see poly extrude. Okay, it's the same with bevel as well. There's a poly bevel, but that's just bevel. Okay, and so we're going to plug this in, and then on our poly extrude node, now you see nothing actually changed because everything is set to default, and the defaults have kind of no values to them. But here we can set our distance with a slider, and you'll see the slider is set to be at 0 at default, but when it's set to 0, it's in the middle. So the slider is specifically set up so we can extrude in the opposite direction if we want to, or we can extrude inwards, so you can choose. So in this case, we're just going to extrude a little bit in the positive, okay? But then there is another option. Now I don't want to inset here because we are just creating the thickness. We're going to do another sort of method for getting it. Well, we can inset if we really want to, sort of this front edge. But here I don't really want my window frame to be thinner at the inside, so I'm not going to inset. Now you'll see here, this is hollow, right? We've extruded, but by extruding, you see if I disable, so if I bypass this extrude node and re-enable it, you can kind of see what's happening. It's moving that edge and it's creating that extrusion, but now we're losing the edge from where it used to be, okay? That whole polygon group on the inside. And sometimes that's what you want, but in this case, I actually still want to keep that. So it's just an option. If we go down, under the extrusion tab, you'll see here it's got a tick on for output front and then output side. So the front is the literally the front of that extrusion, so the polygons we had selected before. The side is, you know, the sides over there. And then output back is off by default. But if we switch it on, we now get the back, and we've got the sides and the front. See, if I switch off front, then we end up with something hollow again, or I can switch off the sides to end up with this. Okay, so there's a lot of cool options. So here we are, we've created a window frame. And what I want to do here, so this is one of the really cool things with working with Houdini, and it's something sort of a way of working with these nodes that you're going to get used to the more we do it. Because these are live, it means we still have access to our original wall. So I can move my display and render flag here, and I look at my wall. It has no hole cut in it, it has no window frame, nothing. It's just a wall. But if I move right to the end of the stream, we've now got a window frame, but we don't have a wall. We've lost our wall because we actually deleted it over here in our blast node. See here, we cut the hole, but now we kept those inside edges, and so we've lost the whole wall. But because it's live, we can kind of grab access to nodes that are upstream, you know, and merge them together. Okay, so you'll see here at this point on our Boolean, we have what we want. We've got a wall that has a hole in it, and if we then in our network view, we hit tab and we type merge and we drop this down, plug our first input. So I plug that into merge. Okay. But because merge has this line, it can take multiple inputs. We're going to also take this part. So you'll see here when we move our display flag to the poly extrude node, now we have our, this is the result that we kind of want as well. Well, let's merge that. So if I now move my display flag to the merge, you'll see we have both the original wall and our poly extruded sort of window frame. Okay, so this is what's really, really cool. We can kind of grab access to multiple parts of our network. I mean, we could have grabbed our original wall if we wanted, but then it won't have the hole in it. But you can sort of merge as many things as you would like. Okay. Now, one thing here, just to make this stand out a little better, I'm going to actually drop down a color node, put it on. Now you'll see I'm inserting it only on this stream, okay? Which means it's only going to affect the poly extrude. So in other words, it's only going to affect our window frame. We're going to give it a color, something that'll stand out. I don't know, I'm just going to give it a blue color. And then when I go back to the merge, you'll see our window frame is blue, but our wall is not. If this color node, if I shake it so it detaches it and I insert it on this side, then it would color just the wall. And if I shake it to get rid of it and insert it after the merge and move our display flag, then both of them are blue. Okay, so in this case, I want my frame to be blue. But one thing I don't like is that it's kind of flush to the side of the wall. I'd like it to stick out a little bit. So I'm just going to actually hit tab. I'm going to chuck down a transform node, because all we really want to do is scale it up here a little bit along the Z axis. Okay, so I'm going to hit transform and scale it along Z. So we look at scale, we look at Z, and then I'm going to increase that a little bit until we have a little bit of an overlap over there. Okay, so now this is an example of a scene that we would maybe have in Houdini. Okay, in fact I'll go back to smooth shaded so we can sort of see the result. And now we have a window cut into a wall. But let's sort of, I'm going to show you now what the pros to this are, but then also the cons, and then how we can kind of work around the cons. Okay, so let's move our box around. Okay, so let's take our window, our original box that's gonna be used to sort of cut it, and in fact go to the transform node over here, because this is the one that's setting its position. Let's hit P on the keyboard to open up our parameters, or with the transform selected in your viewport on the left, you can click show handle, and so it'll actually, the handle will appear in here. Okay, now what's really cool with it being procedural is as we move it, you see it's literally just moving that window in the wall. Because it's live, it's got our wall, it's calculating the cut based on where we've moved this box, and then based on that cut, we're selecting the inside edges, extruding and creating the window frame. So no matter what we do here, we can move it backwards and forwards or up and down, and it works totally fine. Okay, until we cross over the boundary. All right, so let's have a look at what's happened here. So if we look, you will see that it has actually created a windowsill on this edge. I mean, it actually looks quite cool, but it's not what we want. So it's got this edge on the top, right, bottom, and then the left-hand side of the wall. Okay, why has this happened? Right, well, let's examine this. If we go to our Boolean node here, you'll see that it has cut out sort of overlapping the edge, right? So instead of cutting a hole, it's sort of inserted a notch. Now, when we look at this, it means that we have three faces, three polygons here, 1, 2, and 3. But remember, on this blast node, we are specifically selecting 4 primitives to keep and use those primitives to create our window frame. So you see here, we now have 4 polygons. The 4th one that's being sort of inadvertently selected is this side of the wall. Okay, and although it does kind of look cool, that's not what we wanted to happen. You'll see the same thing kind of happens if we move this to somewhere else, maybe up at the top. Then strange things start to happen, like we go over the top, it selects that one over here. So, you know, this is not what we'd hope to see, right? So let's fix that. So we're going to go to our blast node over here. Instead of selecting specific primitive numbers, we would like to rather do something implicit. In other words, something procedural. So we want to say, well, I don't want to go and have to, every single time I adjust this window, now make sure that the selection is correct before it creates my window frame. I just want to tell it, hey, just use the edges that were created by the Boolean function. Okay, you know, you went and cut a hole, just use those same edges. And fortunately, the Boolean function can help us with that because it allows us to create groups, right? So groups, it's just literally geometry that is in sort of a named group. So if we look at the bottom of the parameter sheet of our Boolean node, you'll see that there are a bunch of output primitive groups, and none of them are selected at the moment. You can switch them all on if you want. And what these are going to do is, by switching them on, it says, yes, create this group. Here's the name of the the type of the group. It is the label of our parameters, but this over here, this text, is the name of that group. And we can override this. So if we want to if we want this group, the A inside B group, but we just want to call it something else, we can call it, something else, and that'll be fine. Okay. Now, if we middle click on our Boolean node, you'll see here it has created a bunch of groups. And actually next to the group, it says how many primitives are in that group. So some of these groups are actually not very useful to us because some of them have 0 in it, right? But you'll see that the B inside A group has 3 primitives. Also, our reversed group has 3 in it as well. But in this case, what I actually want to do is just use B inside A. And that's because what it means is B, in other words, our box, so it's the edges of our box, our window box, that are inside of the wall, which is our inside edges. So we actually can switch off all of these ones except B inside A, right? The reason we should switch them off is because the less information we have to calculate, the lighter our system will remain. So this is calculating 3 primitives in that group. And if this was moved away from the edge of the wall, then if we middle click, you'll see that it has 4 primitives in this B inside A group. So that is essentially implicit. Okay, based on what's happening, it is creating a new group. And now instead of relying on just specific numbers, primitive numbers, we're going to delete that. And instead on this drop-down list, we're going to click here and you'll see it's already found the B inside A group that exists. So we're going to click that group. And so now we're using a group that is being created by this node. And that is essentially, in essence, that is proceduralism. Like I said to you, the moving of data and attributes is very important when it comes to proceduralism in Houdini. And that's what's happening here. This node is creating a group, which is data. It lives on our parameter sheet. And this data moves to the next node, moves to the next node. It is carried with us, okay? And so every node can rely on that data. So instead of 6 to 9, we have B inside A. Now we can extrude, give it a color, scale it up and merge, and everything looks fine. But if we go and move it over the edge again, like what we had before where it was breaking, so we can we'll just move along X here. You'll see when we go over the edge, it's perfectly fine, okay? It is 100% happy to move over the edge and go from having 4 primitives that it creates a window frame from to now 3. Or if we move up along Y, you'll see when it goes up over the top corner, it now has only 2 primitives that it's turning into an edge. And if we middle click on Boolean, you'll see here that our B inside A group is only 2. Okay. And the one really cool thing with this is not only does it recalculate wherever we position it, but if we on our wall have more geometry, so if we go and change this to polygon mesh and we change the amount of divisions, you'll see that nothing weird is happening. But if we had gone and set to our 6 to 9 group, then crazy things start to happen. Okay, so as we adjust our our divisions here, you'll see really weird things happening, because what's happening is there's more information here, there's more polygons and primitives. And this is what I was saying to you before. If we rely on primitive numbers or point numbers and primitive counts and point counts, so specifically these numbers, then when they change, it will not work. Okay, we have to be very careful if we ever rely on those numbers. Okay, sometimes you can. It really depends on whether you know your information, your numbers are going to be changing or not. I mean, this is kind of cool if this is the effect we were after, but it's not. We wanted to create a window frame. So instead, using implicit information by creating a group allows us to then make it fully procedural, which means we can readjust our wall. Or there's even something really cool that we can do. If we copy and paste our box and transform, right? And then let's merge these two together. So I'm going to insert this over here and plug it in over there. Okay, so now we have our two different windows that are merged together. They're merged over here before going into the Boolean. Now, obviously, we would like to go to the second one, click on the transform, and maybe give it a different position. Okay, so let's move it over and down. Okay, now we have two windows being cut. And then when we middle click, you'll see that the B inside A group has 6 because we have now our whole window frame and the edge there, which has 2. And so when we create this, it isolates those, we extrude them, give them a color, transform, and merge. Well, at the end, we now have 2 windows. Okay, and we could even do as many as we want. So we could copy this, paste it again, plug it in, and then move this window, and we end up with a different window. And you can do also weird things. We can rotate these windows as well to get kind of slanted windows, or maybe rotate this axis to get kind of weird, like really crazy things happening. And because of the way that these nodes are all linked, it's all procedural. So things can be totally readjusted. In fact, we can go and change the size of our wall now, and it will readjust itself. So as soon as the wall gets big enough to encompass the edge there, then it now has 3 edges for the window frame then instead of 2. Or if I keep shrinking it, then this edge actually shrinks away and our window frame still calculates itself perfectly. Okay, so we can keep shrinking it and then cool things happen like that, right? If we didn't rely on procedural information, then we would never be able to create something like this. Okay, so this is proceduralism, and this is why we need nodes that have a live link, parameters that can hold expressions, and attributes that pass data on from one node to the next to the next. Okay, I hope that now makes a lot more sense. I know this is sort of a long explanation, but really this is the most important thing you need to understand about Houdini, because from this point, we're going to rely on all of this information to start building up and learning how to do simulations, because in the next lesson, we're going to discuss simulations, and really the basis of simulation is proceduralism. And once we know how to simulate, then we can create amazing effects. Okay, see you in the next lesson. Hello, everyone. Okay, so let's move on to the final aspect that makes up the sort of foundation of Houdini, and that is simulation. So really, when it comes down to it, simulation is basically just proceduralism plus time. Okay, the thing is, without the ability to be procedural, then time can only do a few things. Yes, you can keyframe things, and that doesn't require something to be procedural. But in order for something to be simulated, in other words, sort of calculated or figured out, but without manual keyframes, then you need it to be procedural. In other words, you need it to have rules and laws that govern how it should act, instead of explicitly saying how something should move or behave. And that is really the essence of what simulation is. And in fact, the whole purpose of simulating is really just creating animation, but in a much more efficient way. Of course, you animate characters, you set keyframes and you move a small number of objects because that is manageable. But as soon as you have a whole glass of water and you have to move every single particle of that glass, well, so that the water in the glass, you have to simulate it. There is no way that you would ever sit down with an animation team and assign a cluster of particles to everyone in the team and have them spend weeks animating a perfect glass of water is spilling over. It's way too manual and such a waste of time. Instead, we can have those particles move, but based on laws and rules. And that is the same thing as proceduralism. It's just that we've added the element of time to it. And not only is it time, but it's time that is aware of the past as well. And this is a very defining feature of simulation, is essentially it doesn't just perform an action. It performs it based on what it was last frame. So if we take a sphere, for example, like I have here in the center of my scene, and just transform this by 2 units on X, so it would move just to the right here. If we just did that repeatedly, frame by frame, then it would just go from the center to 2. And then on the next frame, it would go from the center to 2. And then the next frame from the center to 2. That doesn't get us anywhere, okay? Instead, we have to say, okay, you move from the center 2 units on X, and then on the next frame, it starts from this new position and moves another 2 units, and then another 2. And so that's how you would get this sphere moving 2 units to the right on every frame, is the fact that it is aware of the previous frame. Okay, so these, just in a nutshell, are all the sort of fundamentals of what a simulation actually is. Okay, so hopefully keeping that in mind, especially if you've never done simulations before, if you keep that in mind, and when we move on to doing actual effects and simulations, you'll see how simple it can be. Because a lot of the times when we move to learning about simulation, it can get a little bit overwhelming, because it's very different to building a piece of geometry. We've got this element of time and all these rules, and it becomes very confusing. But actually, if you just remember that it's procedural rules plus time, then it is actually a lot easier to kind of dissect it. All right. So I'm going to jump inside of this geometry node I have over here, and I'm going to show you a little bit of an example that's just going to show you kind of fundamentally how we are applying what I just spoke about. Okay. And then after that, we will then be moving on to actually applying everything we've learned in all these fundamentals to actual simulations. Right. So I'm going to dive inside. Now I have several nodes here, but these are just sort of different separate phases that I want to teach you about. So really, we're going to zoom in on this first one, and I'm going to show you what we have here. So we have a sphere, okay, just a very basic sphere, default at the origin. Okay, I've changed nothing. And then I have a transform node. And the only thing I've done on this transform node is I have animated my Y value, okay? So it starts up here at 10 units up. In fact, if I select it here, you'll see my keyframes. And I've gone and manually keyframed it so that it lowers down to the origin to the point where it touches the base. Okay, so it's actually 1 unit up because that is the radius of this sphere. And then it rises back up again. So it essentially bounces off of the ground plane. Okay. If I click play, you'll see we've created a single bounce, right? Not the best bounce in the world. We haven't really applied squash and stretch and, all of the animation principles, but, good enough for our purposes. Now, you could go and animate a sphere, of course. That's not too bad. But what if we want lots of spheres? What if we have 100 spheres, okay? And we wanted to animate them all bouncing. Now, maybe if they were all exactly aligned like this, right? And we had them bounce, well, you could probably just have them all be transformed up and down by the same sort of animation, because, if they all start from the exact same height, they should bounce the same way, right? I mean, that is kind of presuming that they all are the exact same height and weight and have the same material and everything, okay? But what if they have all different heights? So now they have a different amount of momentum and acceleration and just there's a lot of different things going on here. Well, you would have to sit and animate every single one of these, and that's a pain. So instead, what we can do is essentially apply some proceduralism here. Okay, so apply some of what Houdini has as sort of its most powerful features, right? So let's go back to a single sphere, and let's assume that I animate this. But now instead of animating it to go down and up, I just have it animate down. And then I build a rule. Now don't worry too much about the code and everything that's going on here. This is just to illustrate a point, right? So I write some kind of line, or you could do it with nodes and other things, right? To create some rule that says that it will, when it hits the floor, will bounce back up now instead of just going through the floor, right? So when I display flags on this transform, we simply go down. But you'll see here, if I put my display flag to the end after this node is applied, and then I just click the template of this node, so now we can see the result. We'll see the difference really between these two. Okay, the solid sphere is the one that has the rule applied to it. The wireframe is just going to be animated straight down. You'll see here they move together until they bounce on the floor. Okay, well then the one bounces and the other one keeps going. So ultimately the rule I created here was just that everything should be mirrored around the sort of the y-axis at the point of 0. Okay, and now we go and take that exact same code but apply it to the 100 spheres that are all at different heights, right? So we have them all animated down, so they all move down. But now apply that same rule, and because they all individually get reflected at a different point, they would now all bounce at a different moment in time. Okay, so here we go. If I click play, you'll see they all bounce, right? So that's better. That's headed in the right direction, but there's no variation. Also, there's only a single bounce, and now, sort of reflecting around the y-axis is one thing, but now at the top of the arc of each one of these, it would have to now turn around and start heading back down. Some of them will not bounce as high as this because actually they started much lower, so they should actually sort of bounce not quite as high. So this is still not even perfect, but it is kind of heading in the right direction. So what we need to do now, this is essentially using proceduralism, and then yes, it has time, but it's sort of animated. Instead, if we had to include a rule like this, okay, something similar to this that says, hey, you should bounce when you hit the floor, and also kind of this keyframe here was really just a way of making it move downwards at a set rate. In other words, gravity. So this really represents gravity, and this over here represents a collision. Okay, well, instead of having to kind of try and manage this manually, Houdini has a pre-built sort of network type, which is called DOPS. So we've discussed this previously, the dynamics operators, which are specifically designed for creating these rules within your simulations, and then sort of being able to remember what the previous frame's positions were, or the sort of the state of everything, and kind of carry that forward into the next frame, but then continue to apply the rules and then pass that information to the following frame. And that's really how a dynamics operator works. Okay, so we have the exact same setup here. There's the exact same 100 spheres over here. You can see when I switch, nothing changes. But all we've done is created a dynamics operator, well, a dynamics network. And then inside of here, again, don't worry about really this exact setup. We are going to be going into rigid bodies and doing all of this manually in future. But just for now, the principle that we're doing is we're saying, fetch those 100 spheres and then simulate them. So this over here says simulate them like they are solid objects. But here is gravity, so it says move it downwards by a certain amount every frame, and this here says but bounce on the ground. Okay, so the equivalent these two nodes combined give us the equivalent of this collision, and this gravity node over here is the equivalent of this, except that they are inside of a DOP. And so this DOP is going to go frame by frame, calculate those rules, and remember what happened previously. So when we hit enter, you'll see that they now bounce, and they bounce properly, right? So the ones that were lower to start with would bounce a lot less, bounce a lot higher, eventually, come to rest a lot quicker. Now you'll see they bounce a little too perfectly. There's no roll in them at all, but that's because we have given absolutely no kind of variation in this simulation. The only force applied is downwards, but we could create some kind of random rotation, some drag, all sorts of things that would then have these balls react a lot like you'd expect them to. If you had 100 bouncing balls and dropped them, you'd expect them to kind of bounce and roll, and maybe even as they roll, bounce off of one another, and so on. Okay, but either way, we have a much better bouncing ball simulation here that is so quick to set up and doesn't require us to have to go and manually animate 100 different balls. And so this over here is really the kind of the progression of the thinking behind simulation. We want to apply some kind of effect. A lot of the time it's motion, but sometimes it's also deformation. So we want something to change shape or change state entirely. Okay. And so we want to do that, but we want to do it progressively over time. But instead of doing it manually, we want to do it with a bunch of rules. In other words, procedurally. So just as a kind of a summary, we can see how from this, we can see how simulation is based on proceduralism, how proceduralism is so important to Houdini, and really how proceduralism comes down to essentially a hierarchy of nodes that are live. Okay, so they have kind of a processing order, and then the parameters on those nodes that determine the sort of the state of things, and then each node passes data from one to the other. Okay, so from our grid here, it has certain information. That information is then passed on to this node and to here, and everything passes its information forward. So we see how nodes, parameters, and attributes form the basis of proceduralism, and how proceduralism forms the basis of simulation. Right. And this is really what we need in order to be able to do effects and essentially to use Houdini. I mean, Houdini can do a lot more than effects. In fact, it really can do everything. But this is its most powerful feature, is it's mostly used for effects. Although I'm going to show you in this course how I believe it's one of the best rendering systems, especially because of this, because we can use rules when it comes to rendering. It's a way of handling lighting and rendering, but almost from the mindset of an effects artist instead of just from a lighting point of view. When you learn this proceduralism, you could have your renders, you could actually save time by applying rules to your renders. So it's almost like simulating a render instead of having to manually set up every one of your passes. And that's what's super powerful about Houdini. Okay, so I hope that was helpful and clear, and you will hopefully understand this a little bit better as we progress as well. Keep these rules or these this sort of diagram that I've shown you in mind. As we move forward, you'll see how it is applied, and then maybe later on come back to this first week and go through it again, because the better you understand these principles, then the whole of Houdini kind of opens up to you, and you'll find that you can literally do anything. Okay. Right, so thank you, and I'll see you next week. Hello, everyone. Okay, so I just want to wrap this week up by discussing basically what your assignment will be so that we can solidify everything we've learned this week. Now, primarily, especially because this is the sort of the intro week and just getting you started, I don't want to assign you sort of too much of an overwhelming, very specific set of tasks. Instead, what I would like you to do is play around. Just play with Houdini. Now, we started this whole week with an icebreaker All right, so remember we made some lava. We actually just used the shelf tools here to create an effect. And this is really what I would like you to just do this week. Just take some time to play around with the shelf. Do not worry if things break, okay? If stuff breaks, it's really as simple as going File, New, or I don't know, if your whole scene crashes or something, whatever, just close Houdini, open it up again, and then try again, right? But the sort of the fear of what to click and I need to do it perfectly, that is something that will hold you back a lot. And so I would encourage you to just play, just actually break things, okay? Try crazy simulations, combine different things. Some of them are not going to work because some of these, even the shelf tools, are actually a bit complicated. Some of them expect you to have specific things set up and it's asking you to select things in a certain way that just doesn't make sense. You can't just click any button and it'll do something. So you will find that some just don't work, but that's okay. Don't be afraid of that. Just let it be, right? But just try to use the shelf tools and get familiar with this, okay? So first of all, follow the icebreaker lesson so that you can at least create your first effect. And then try to sort of almost follow similar steps, but just with different tools, different shelf tools. Go to a different tab and see what these are and just play around, okay? It's just really a way of becoming more familiar with the program, learning, practicing sort of navigating around the viewport, going in and out of node networks, and it just gets you familiar and more comfortable with Houdini. The understanding will come later, but we need to first get you sort of dip your toe in, really, actually get started, right? So just the best way is really just to drop down some piece of geometry and then look for shelf tools. As I've always said, the best thing to do is have a shelf, have nothing selected when you click the shelf tool, just so that you can kind of read the questions that it's asking you. So maybe we say here, flip fluid from object. Let's see what that does. Asks us to select a fluid, an object. So let's click our object, hit enter, and it isn't asking me any more questions. So there we go, and I have something. Well, let's have a look at what it's created in my scene. So it's created 3 nodes over here. I had my sphere before. Let's see, has it done anything to the sphere? Nope, just one. But it's created an auto dop network. There's a few nodes. Don't know what those do, but we'll figure it out. Oh, there's a couple of nodes here. In fact, you'll remember this very similar setup in our lava. But you don't really have to understand exactly what it's doing, but just click play. See what happens there. Go, okay, well, that fell through. But remember, we did in the lava lesson, we created a ground plane, so we know how to do that. So let's click that, see what happens. Okay, there we are. There's a simulation. We could then just go File, New, and just do something else, right? Again, just drop down a piece of geometry and then click a different shelf. Just click on this and click Explosion. That sounds really cool. And then just let it calculate. And then hit play and see what happens. Okay, pretty cool. So it really is this simple. I just want you guys to play around. And then just don't worry too much that later on, understanding will come. We're going to go through all these different types of effects. I'm going to explain why they work a certain way, all of the kind of the theory behind it. But first thing is you can just click that button and make it fun, right? So that's all I would recommend for this week, is just to play. So what I would like you all do is take one effect, one shelf tool over here, one that we haven't used, so maybe not an explosion or a lava thing, something different that we haven't clicked, and just see if you can get it working. Okay, that's all. More than anything, I want to see that you have, not just sort of watched the theory, but actually are trying to do something with it. Okay, and then next week we are going to dive into geometry, where we're going to do a lot more SOPs work. So it will not quite be, we won't really be working with simulations yet, but what we're going to do is learn a lot more about how the nodes in Houdini work, especially at SOP level, all of the things you can do with procedural modeling and how we can alter geometry, work with groups, all these kinds of things, attributes and VOPs and all that type of stuff, so that because that is really what the basis of simulation is. You need to have good geometry in order to simulate. So we're going to start with geometry, and then the following week will be simulation. So let's just play around this week, and then next week we're going to move on to much more SOP-based work. Okay, so thank you everyone, and I look forward to seeing your assignments.